I call this meeting to order. Welcome to meeting number 24 of the House of Commons Standing Committee on Science and Research. Today's meeting, as you know, is taking place in a hybrid format, pursuant to the House Order of June 23rd, 2022. Members are attending in person in the room and remotely using the Zoom application. Tonight, we are continuing based on the order, Standing Order 1083I, and the motion adopted by the committee on Monday, September 26, 2022. We are continuing the study of the International Moonshot programs. I'd like to make a few comments for the benefit of the witnesses and members. Please wait until I recognize you by name before speaking. For those participating via video conference, click on the microphone icon to activate your mic, and please mute yourself when you are not speaking. Interpretation for those on Zoom, you have the choice at the bottom of your screen of either floor, English, or French. For those in the room, you can use the earpiece and select the desired channel. A reminder that all comments should be addressed through the chair. For the members in the room, if you wish to speak, please raise your hand. For members on Zoom, please use the raise hand function. The clerk and I will manage the speaking order as best we can, and we appreciate your patience and understanding in this regard. In accordance with our routine motion, I am informing the committee that all witnesses have completed the required connection tests in advance of the meeting. I see tonight that we have Mr. Pulowski, Mr. Williams, and Mr. Guerin are joining us tonight. Welcome to you all. And now I'd like to welcome our witnesses. Appearing as an individual, we have Dr. Art McDonald, the Gray Chair in Particle Physics, Emeritus at Queen's University, and of course, a Nobel Prize winner. And we also have Gerard Moreau, Center for Ultrafast Optical Science, Dr. Brandon Russell, who is a research fellow. I would like to welcome you both. Our committee is very excited to hear your testimony. You will each have 5 minutes to present. At the 4.5 minute mark, I will hold up this green card that lets you know there are 30 seconds left, and we aim to be fair, so if you could wrap up your discussion to be within the 5 minutes. With that, I welcome you again. And if we could hear from Dr. McDonald, the floor is yours for 5 minutes.
The opportunity to speak to you this evening. I want to let you know that Canada is in a position to compete at the very forefront of the field of particle physics and astrophysics internationally through the presence of SNOLAB, the lowest radioactivity laboratory in the world, 2 kilometers underground near Sudbury. SNOLAB experiments are addressing questions that are also the strong focus of the largest accelerator facilities in the world, the Large Hadron Collider at CERN, Fermilab in Chicago, and the J-PARC Accelerator in Tokyo. The results of these experiments in future that will exist at SNOLAB can have a greater scientific impact as we had with the Sudbury Neutrino Observatory, for which a Nobel Prize was awarded in 2015. These questions are absolutely fundamental to our very existence, to the composition of our universe and the way in which it has evolved, and they're the top of every list of scientific questions internationally. First, what is the nature of the dark matter that holds our galaxy together and appears to have 5 times as much mass in the dark spaces between the stars as in the stars and us, of course, itself in ordinary matter? We have a very remarkable and complete picture of how the universe has evolved since the Big Bang about 13.5 billion years ago. And the gravitational effects of dark matter are essential for an understanding of that, which has now reached a complete nature with the exception of what is the dark matter. It's completely unlike any of the particles, any of the matter that we have identified on Earth in any of our experiments to date. The Large Hadron Collider is trying to produce them for the first time here on Earth hoping that they have as high energies as necessary to do it as was available in the original Big Bang. But we know that those dark matter particles exist in our galaxy. We are moving through them. And with our experiments at SNOLAB, we are creating a ultra-low radioactivity environment to get rid of everything else except perhaps signals from those dark matter particles hitting our various detectors. We've made considerable progress in the development of detection techniques already at SNOLAB, and there are major international collaborations, in some cases with more than 400 scientists from 90 institutions in 14 countries, that have designated SNOLAB as the location for larger scale experiments such as ARGO. It'll push the sensitivity for dark matter detection by factors of hundreds of times greater than today's sensitivity, to the point, ironically for me, where the only interfering background in the experiment will be neutrinos. So such experiments will cost upwards of $300 million, with substantial contribution, however, from international partners, a lot of those contributions being spent here in Canada. At least one of these will be seeking funding within the next 10 years. Secondly, from a physics question, it appears that the Big Bang produced equal numbers of particles and antiparticles like positrons, the antiparticle to electrons. Almost all of those antiparticles have decayed away, leaving us a universe dominated by the ordinary matter from which we and the stars are formed. There's a theory as to the fact that that decay in the early universe was dominated by processes involving neutrinos. The experimental programs at Fermilab in Chicago and J-Park in Tokyo are dominated by searches for properties of neutrinos that are needed in the theory in order to understand how the antimatter decayed in the early universe. These are multi-billion-dollar programs with strong international participation. A further part of this theory is explored by the ultra-low radioactivity measurements at SNOLAB. Neutrinoless double beta decay is the rare radioactivity we seek. The two foremost international experiments of this type, each of them in excess of 300 million, have declared that SNOLAB is their location of choice for their site. We also may need an expansion of SNOLAB, which could cost in excess of 200 million in order to accommodate these future large experiments. These are moonshots, building on Canadian leadership in one of the most fundamental and internationally visible areas of science. And we have the stepping stone to that through SNOLAB, although granted, going 2 kilometers down doesn't exactly seem like a moonshot. SNOLAB was created by a CFI program in 2003, which was designed to bring international scientists to Canada to work with Canadians.
Dr. McDonald, I am so sorry to interrupt, and you're giving us such interesting material. To be fair to everyone, I know our colleagues will have many, many questions for you. So I apologize for interrupting. And if I could go to Dr. Russell now for 5 minutes, the floor is yours.
Thank you. Hello, everyone. I would first like to thank the committee for inviting me to discuss the research that is being performed in the field of plasma physics at the Gerard Moreau Center for Ultrafast Optical Science. My name is Brandon Russell, and I'm a research fellow at the University of Michigan, where I recently completed my PhD in electrical engineering. Although I'm currently working in the United States, I grew up in Alberta and attended the University of Alberta for my undergraduate degree. During my time at the University of Alberta, I was initially involved in research in the field of nanotechnology. However, through an internship at the Stanford Linear Accelerator National Laboratory in California, I was introduced to the field of plasma physics. This is an extremely exciting and impactful field of research, and I've been passionate about it ever since. My graduate studies were focused on progressing the high energy frontier of this field, where large, ultra-intense lasers are used to create extremely energetic plasmas. My current research is focused on creating the theoretical framework needed to design experiments for the next generation of laser facilities that are currently being constructed around the world, including the Extreme Light Infrastructure, or ELI in Europe, and the ZEUS laser system at the University of Michigan, which will be the focus of the speech. Prior to the funding of ZEUS, In 2019, by the National Science Foundation, the University of Michigan had the Hercules laser system. Hercules was a mid-scale laser system, taking up several laboratory spaces. This laser was built under the leadership of Gerard Moreau using the technology of chirp pulse amplification, for which he jointly won the Nobel Prize in 2018. This technology allowed the laser to reach extremely high intensities, large enough to accelerate electrons to a significant fraction of the speed of light. In fact, the Hercules laser held the Guinness World Record for the most intense laser in the world. Many experiments were run on this laser, both internally by students and researchers at Michigan and by external collaborators. These experiments studied a diverse range of topics, including particle acceleration, X-ray generation for medical and material studies, and the study of magnetized processes relevant to astrophysics. Since then, many similar laser systems have been constructed throughout the world, including many more powerful lasers called petawatt laser systems. For reference, the United States power grid operates at around 1 terawatt, 1,000 times less than the power of these laser pulses generated by these petawatt laser systems. In North America, many of these laser systems belong to LaserNet US, a network of laser systems that researchers can apply to for time to run their own experiments. Although the majority of these lasers are in the US institutions, the Advanced Laser Light Source in Quebec also belongs to this network. These mid-scale laser facilities allow us to tackle scientific problems with a significant impact at the level of fundamental science and the potential to have great societal impact. Some of these problems include accelerating electrons to energies comparable with those of conventional several kilometer long particle accelerators, creating compact X-ray sources for diagnosing advanced materials and ultrafast medical imaging, proton acceleration for cancer therapy, and nuclear fusion as an alternative energy source. However, it should be noted that nuclear fusion experiments are generally performed at large-scale laser facilities, including the National Ignition Facility in California. Recently, there's been an international push, largely in the United States, Europe, and Asia, to develop a new generation of multi-petawatt lasers that can access an extremely energetic regime of physics where strong field quantum electrodynamic processes can be studied. These processes that appear in this regime are theorized to occur in the most extreme astrophysical environments, like those surrounding black holes and highly energetic stars known as pulsars. Given a high enough laser intensity, we could achieve this regime by simply shooting a laser into a vacuum. However, such intensities are far outside the reach of current laser technology. Instead, we can achieve similar results by colliding a high-energy electron beam head-on with a laser beam. Several facilities around the world are currently racing to apply this concept, including the University of Michigan, where the Zeus laser has been purpose-built for this concept. The Zeus laser was funded by the National Science Foundation to be a user facility where researchers can apply to run their own experiments. The facility recently ran its first experiment, successfully demonstrating operation of the first components of the laser system, and is expected to begin operation at full power in late 2023. At that time, it'll be the most powerful laser in the US. This facility has already brought together talented scientists and students for the design and construction of the laser, and will continue to bring in researchers internationally to perform experiments. Collaborating on novel, highly impactful experiments at this facility will allow students to receive a unique set of skills and gain useful connections for their future careers. For these reasons, I believe the work being done at the University of Michigan and generally in the field of plasma physics is in line with the motion adopted by the committee. I hope that what I've talked about can give insight into how laser plasma physics, which already exists in a few institutions in Canada, may be expanded upon to bring in talented researchers. I would again like to thank the committee for giving me the opportunity to speak about this work being done at the Gerard Moreau Center for Ultrafast Optical Science at the University of Michigan. I'm happy to take any questions. Thank you.
Thank you very much, Dr. Russell. We're delighted to have you and Dr. McDonald tonight. I know our committee is eager to ask you both questions, so we will now hear from our members. We begin with the 6-minute round, and tonight we begin with Mr. Soroka. The floor is yours.
Thank you, Madam Chair, and thank you to the witnesses. And I'd like to start off by probably asking my nephew a question, and Dr. Russell, so he is invited tonight. A little bit of nepotism there, I guess you might say. Now you can understand why I don't understand what he's talking about half the time. But, you know, you did have to leave Canada to go into the States for plasma physics. What do you think we can do to improve better research or better understanding of plasma physics here in Canada?
That's a very interesting question. I think this is generally true for all fields of science, including what Dr. McDonald also talked about. I believe Canada needs to develop some sort of unique facility with unique capabilities that bring in international interest so that such that people trained elsewhere can come to Canada to work, or Canadians will have a place to work. Such a facility should be strongly advertised and should provide internships to graduate and undergraduate students and provide clear long-term career paths. So they stay in the field of plasma physics and continue contributing to it, and such that they stay in Canada. This is effectively the model of national laboratories in the United States, which hire a significant fraction of graduate students from many areas of science.
So with that, are you saying that a lot of other countries are coming to the States simply because of the facilities they have, or is it just the amount of dollars that they're contributing to it?
Definitely the facilities. There's a significant number of facilities of bringing more people to the U.S. and creating sort of a united effort in developing plasma physics because they were falling behind Europe and Asia, which were developing far ahead of the U.S. They have these multi-petawatt facilities that are being created, like the Eli extreme light infrastructure.
Okay, with the Zeus laser system that's being built in Michigan, do you kind of have a dollar figures to give us an idea of what that would cost us here in Canada?
Yeah, the initial funding from the National Science Foundation was around $16 million US. And there's been some operating costs that have been added on to that since.
Through this Zeus laser system, what is the primary thing you're hoping to accomplish, or what are the moonshot thing that you're hoping to really develop from this system?
Sure. So the Zeus laser facility, the primary or flagship experiment is this colliding beam experiment, which will allow us to access a new regime of physics that nobody has really been able to look into previously. However, there's so many diverse and vast research areas that you can go into in plasma physics using this laser. Specifically, even on the Hercules laser system, we've had many spin-off companies come from that, including a form of LASIK eye surgery. And we have the ability to study things like nuclear fusion and medical imaging, cancer therapy on this facility.
Okay, well, thank you for that. I'd like to now ask some questions of Dr. McDonald. You had mentioned about the Snow Lab. You want to increase expansion of it. Is this an increase of size, or is this just increase of research that you're planning on doing there?
Well, it's potentially an increase in size, possibly generated by the fact that the scale of these experiments in both the areas of dark matter research and neutrinoless double beta decay may be larger than the cavities that presently exist. I think there are a couple of stages that could be accommodated within the existing facility, but over the next 5 to 10 years, there need to be plans made because, I mean, basically the world is saying that this is the place they want to come for these frontier experiments, and they are, in a sense, the other half of the sort of things that are being studied at these major billion-dollar accelerator facilities around the world. So Canada has an opportunity to step forward with support for Snow Lab and attract the world and attract significantly large experiments, which may, within the next 5 years or so, require an expansion.
So basically, this is one of those facilities that Dr. Russell had talked about that we need in Canada and we actually have here. Would you say that how many other facilities around the world are similar to Snow Lab?
Well, there are facilities that are similar, but they are not as deep and they are not as clean. And therefore, when you come to the ultimate experiments, which are pushing the frontiers of science and trying to get those questions that have not been answered yet in terms of the model for how the universe has evolved, you want to have the best. Canada is basically the best right now. And that's why these major multi-million dollar, hundreds of million dollar experiments supported strongly by other countries are targeting Snow Lab as their location. And so Canada has an opportunity to step forward by recognizing that we have unique opportunities here. This is something that, in terms of the depth provided, fortunately, by Vale, the mining company, to us on an ongoing basis, we have eliminated cosmic rays greater than anyone else in the world, and it's the only laboratory that has also made the entire laboratory free of dust that contains radioactivity, and therefore an advantageous place to site these big experiments.
So basically, this is our moonshot program here in Canada, and if we don't continually keep investing in it, we're going to lose what we have here. And what kind of...
Mr. Soroka, I'm sorry to interrupt. That was such an interesting exchange between you all, among you all. Thank you, Mr. Soroka. We're now going to go to Mr. Collins for 6 minutes, please.
Thanks, Madam Chairman, and thank you to both of the witnesses for their appearance tonight. I'd like to start with Dr. McDonald, if I could. Sir, I know that for Snow Lab, there was just over a year ago, the province made a substantial investment in the program, and I believe our minister was in Sudbury this past summer to make a very large investment. I think it was in the area of about $100 million. And so there seems to be cross-jurisdictional support from both levels of government to support, in your case, Snow Lab. How would you suggest that the federal government deal with provinces as it relates to making investments in moonshot projects across the country? Do you have any suggestions for us as it relates to working with the provinces and territories in terms of making public investments into moonshot programs?
Well, in testifying to the Bouchard Committee on the future of scientific funding in Canada, one of the topics that I was asked to speak about was, in fact, the major research facilities, and they shared with me the plans that have been put forward by the government, which I think go a long way towards helping deal with the question of how does Canada deal with what are really national labs, even though in a number of cases they're essentially university labs. I certainly would like to see more government involvement and overview on these laboratories. I think one of the things that was actually completely omitted in any of the documentation I've seen so far is the role of the provinces in such situations. And there certainly have been situations in the past where a smaller province has had cited in it a major national facility and has been asked to come up with substantial amounts of funding. I think the existence of this Major Research Facilities Committee and overview on such national labs is something that should lead to a dialogue with the provinces, and in some cases it may be inappropriate for the degree of matching certainly that's been asked for in the past to be included. So I think it's a topic that needs to be on the agenda along with the establishment of such committees. And if I may, I think the types of projects I was talking about, which are international projects for experiments as opposed to facilities, as opposed to something that is expected to house maybe multiple experiments, but they're large scale, on a Canadian scale certainly, it would be appropriate to consider seriously whether this structure that's being set up for the overview of facilities be expanded to consider international programs of this scale that are situated here in Canada. The experiments I'm talking about.
Thank you for that answer. And that leads me to the next question, and that is, how does the government then prioritize the moonshot programs that are out there, and what would you suggest? I mean, we don't have a specific fund right now that is a moonshot fund. So if we're sort of creating policy around making strategic investments, as we already have, and I referenced the $100 million, I think that Mr. Champagne provided to your organization. If the government's looking at coming up with a program, how does it establish or create criteria as it relates to making strategic funding investments across the country?
Let me answer, but let me just start with pointing out that the money that was recently awarded was in fact for the operation of the Snow Lab facility over the next 7 years. It was not capital investment. It was matched, in fact, by the province to a substantial degree. How do you set priorities? It's very difficult. I don't envy you in terms of the government and the advice you're going to give it. Many things come into this. I think you want Canada to be doing the things that are important in science that are going to be of benefit short term with the Canadian public in health and in areas that are clearly something that you want to be a world leader in order to be able to provide the appropriate support to the Canadian populace. On the other hand, I think that it's important for Canada also to be a leader in basic science in certain areas where it has natural advantages. Obviously, what I'm saying is that SNOLAB is a case where we have a natural advantage. We should be building on that because we can be a world leader in natural sciences as well. And I would point out that the people that we educate in PhD degrees, for example, in very basic sciences, go on to a wide variety of other occupations. We did a survey 10 years after the snow experiment stopped taking data. We found that 75% of the people who had been educated in the process of doing their work on the basic science experiment were in a wide variety of other jobs. Not 25% of them were in academic positions, and I'm pleased to say 35% of them were women, which is high for physics and increasing, I'm pleased to say. But the 75% worked for J.P. Morgan, they worked for the government, they worked for medical research laboratories. Basically, they had been trained in evidence-based decision-making, which is needed in all aspects of our society. We could attract them because we had things at the frontier of science. They were trained in such things, including the frontiers of technology, and they have gone out into society and are making contributions across the spectrum.
Thank you to Mr. Collins and
Thanks,
to Dr. McDonald. We're so grateful to both our witnesses. And now we are going to go, I believe it's Monsieur Garon tonight. The floor is yours.
Merci beaucoup.
Thank you very much, Madam Chair. Good evening, everyone. And thank you to the two witnesses for being here. I'll start with a question for Professor McDonald. In our society, there's a lot of focus on applied research that has direct applications that are paying, that can easily be turned into consumer goods, etc. But it almost seems as though it's a precondition for the development of important industries, like, for instance, genome sequencing, all basic research that was produced at Berkeley, for instance, that led to the development to Silicon Valley as a whole. I'm of the view that fundamental research is a public good that should be largely funded by the state. I'd like to know what you think of the idea I've just put forward. And I'd like to hear what you think about where Canada stands in recognizing that this is a public good that should be publicly funded.
I certainly agree that it is very important that there be a balance. What Canada needs is strong support for basic research. I think the funding councils require strong support, and a topic that's on the table is also adequate research for individuals, both at the faculty and postdoc and student level right now. The levels of funding, as we found, I was on the committee that was chaired by David Naylor, and we certainly at that time found that the levels of funding were lower than required. They have been increased, but they are still in difficulty within the basic science. But I think that needs to be balanced with a recognition that there is a need for Canada also to be technologically and commercially related to that, actively involved in the latest in technology, which in a number of instances comes from basic science. And in fact, the type of people that I was describing that go out into industry, even though their degree may have been in basic science, are the type of people that is of value to industry, because they are able to look across the horizon outside Canada at that new idea that came up in Germany or wherever and know what it means, because it is basic science that creates the understanding of when the next technological breakthrough is going to be. And so Canadian industry needs both people who are trained as applied science people and people who are trained in basic science in order for them to be able to access the latest in what's happening internationally when it comes to innovation. So balance, from my point of view, is what's important.
Merci beaucoup.
Thank you very much. A question for Dr. Russell. It's important to draw brains in. We need to have preconditions here in Canada to draw in, to attract brains into the country. I think of the years where there were serious problems with immigration, and many countries at the time decided that they would be in competition with the U.S. to draw in researchers like Australia and New Zealand that did a pretty good job in that respect. At that time, Canada was having a hard time doing the same. In Canada, in terms of research funding and grants for young researchers, do we have what it takes to draw people in when the conditions are right?
Thank you for the question. I think that's very tricky. I don't work in Canada right now, so I don't know what funding exists for professors, for example. But the number of faculty positions that exist in my field are few and far between in Canada. And so actually bringing researchers to Canada is very difficult in my field. And then if you were to build an institute on top of that, you would need to bring people in. So you need the experience already. So I think the funding does not exist, which is partially why I've come to the US instead of staying in Canada. The funding does exist here for me to pursue PhD, postdoc, and then have a career in this field, whereas that does not really exist in Canada, or at least only for a minority of people.
Merci beaucoup.
Thank you very much. This leads me to the following question for Dr. MacDonald. You've seen many students over the course of your career. Most of the federal government grants from the various funding agencies are at the same level that they were at 10, 15, 20 years ago. If we want to be able to have really high quality projects to fund them, but also in a way have a breeding ground for these researchers in the country. On top of thinking about these major projects, should we also focus on those graduate students so that they can start here and they have the opportunity to stay here rather than have to leave?
Major experiments. It's what I am involved in. It's what SNOLAB is good at. It's what SNOLAB can make a place for Canada and train extremely good people with. But I think it's very important to have perspective on the entire funding system. I think that the question of whether or not what is happening with the granting councils in terms of adequate support such that one can attract and retain graduate students across the disciplines is very important. And I think this is something that we certainly addressed in the previous Fundamental Science Review, and I think it's being addressed by the Bouchard Committee right now. I'm very hopeful that will be helpful.
Je suis désolée.
I'm so sorry, Mr. Garon.
That you could join us tonight. I hope you are enjoying being part of the committee. And with that, we will now go to Mr. Cannings for 6 minutes, please.
Well, thank you, and thank you to the two witnesses here before us today. This is a very interesting study and learning a lot, as usual. And Dr. MacDonald, I'd just like to start with you. And, SNOLAB has obviously been a big part of your career, and I'm just wondering if you could maybe tell us, when you started this whole SNOLAB project, did you have in mind these things that you're talking about now, the spin-offs that it might accrue, the kind of experiments that it would attract and that Canada can build on with these big science projects?
Well, I started back in 1984 with the snow experiment, and we had a single thing in mind. There was a big question in science to be answered, and fortunately, with the support we got in Canada, we were able to do so. SNOLAB itself, as I said, was created starting in 2003 by a program that was led by David Sinclair and Carleton University. I was still involved in the SNO project, although I was actively involved in the in the ideas that went into SNOLAB. All of us who were working on it recognized that there really had been a change as a result of the measurements that had been made with respect to neutrinos in terms of the understanding of where those neutrinos fit into the overall model of elementary particles and how that influenced how the universe evolves. The fact that the dark matter was not neutrinos means that we now have other particles to look for that are different than anything that has been seen. And that was a program that we could see, and it was in the proposal to CFI, could be a substantial program going forward. And as I've said, there have been smaller scale experiments that have been taking place in this area that now are leading to, and also the demonstration that SNOLAB itself functions extremely well and is the best place in the world to do these type of experiments, has triggered international interest. And so, yes, it was in our mind as we started out, and we're just fortunate that, well, we were fortunate at the time, and it's an indication of how Canada has progressed in its funding system, that CFI existed. It did not exist when we were trying to get SNO funded, and we had to go to a variety of different hoops, let's say, in order to get it funded. The existence of a single funding agency that can deal with infrastructure in Canada was a real addition to the scene.
Well, thank you. And I mean, you're involved in particle physics and those kind of questions, astronomy, they tend to be a part of science that, at least I think of, involving big science, you know, because of the questions you're asking. You have to get particles moving very fast. You have to look far distances. And, you know, there's always this balance when I'm thinking of policies around funding science, funding big science versus smaller science, I guess you could say, basic science versus applied science. Do you have any, I guess, advice on how you would weigh that? I mean, maybe you're biased, I'm biased, but, you know, we're faced with this. We want to, I think, as a committee, as a government, as decision makers, we want to make science flourish here in Canada and take advantage of the things that we have.
Well, again, I think it's a question of balance. Mm-hmm. There needs to be balance between applied science and basic science in the funding decisions. There also needs to be some fraction of the budget that goes into, moonshots. You want Canada to be capable of hitting on the world scene in a way that it has credibility when its industries go out there and say, this is a technologically literate country. But also you want to educate those students. But I think it is a controlled fraction of the total budget. That's where the balance comes in. And there, I think, again, you want to pick situations where Canada has some natural advantage in terms of your choice of moonshots. In our case, we had the deep mine and the capability of running it totally clean. In other cases, you want to look for similar advantages.
And, you know, when we do have, I would just want to bring up CHIME, which is part of the radio observatory near my hometown of Penticton, a National Research Council facility. You know, it's a considerable expense went into that, but it's discovering things already that I think is far beyond what we initially thought.
CHIME is a wonderful example of Canadian ideas that basically revolutionized radio astronomy in certain areas. Instead of focusing a telescope on a small fraction of the sky, you look at the whole sky and you use very sophisticated data analysis techniques to be able to extract extremely good information from it. And it has made a tremendous difference in understanding a number of very extreme astronomical objects. It's a great Canadian success story.
I think I'm out of time, so thank you very much.
You are, Mr. Canning, said, I'm sorry. This is a really good discussion, and we're very grateful to our witnesses this evening. And now we're going to go to the second round. This will be a 5-minute round. And we start with Mr. Lobb tonight.
Well, thank you very much, Madam Chair, and good evening. Last week we had the Governor General, David Johnson, and today we have two distinguished persons, but certainly in person, Mr. MacDonald. It's quite an honor, I think, for our committee and a testament to our clerk and analysts for getting such top quality people to come out to this study. My first question is, there's been a great discussion here tonight, but just give me an indication with the Snow Lab, how it works financially. Like I know there's financial contributions from the federal government and also the provincial government. If there are projects or studies that want to be conducted, do they pay a fee to the Snow Lab to be able to have the right to practice there, or is it the Snow Labs that welcome the people to do the research there? How does that work?
It has been the norm in particle physics for a particular country that hosts a major facility, let's take Fermilab in the United States, for it to pay for the activities at the facility and for it and other countries that come in to build big experiments to share the costs of such experiments. So, for example, SNO, that did not have a facility, it was a single experiment in a hole in the ground, basically, before Snow Lab existed, was shared between the various countries. It's an experiment. These experiments I'm talking about that would be situated at Snow Lab are ones that would be shared in terms of the costs of such experiments in coming to Snow Lab. And the facility itself would predominantly be run by Canada, although there would be charges for obvious things associated with the electricity associated with running the facility and so on. But running the hoist to get people there and things of that nature, that's a responsibility of the funding that comes through major science initiatives from CFI at the present time, and in the case of Snow Lab, shared by the province of Ontario.
In these endeavors that are very complex, the breakdown of the way it would work specifically on human resources, because it seems to me, and maybe you can tell the committee, are there more people getting into these sciences now? Is there a need for more to get in? Where is the state of the day with these highly educated individuals?
There's certainly a significant continuing interest in these fields. We were very fortunate, for example, in the field of particle astrophysics, which is related to the Snow Lab very strongly, in being successful with a Canada First Research Excellence Fund. And in the process of that fund, which it has been in existence for about 5 years, there have been 15 faculty members across the country recruited. The equivalent number of faculty members in addition that have been attracted to the universities that have built up programs in this area, because this is an area of particle physics that has become very interesting, and Canada is one of the leaders in it. And in addition, there were hundreds, I don't know the numbers, of students and postdocs that have been educated over the last 5 or so years just in connection with that program alone. So it's an example of the fact that not only are individual scientists interested, but scientific departments across the country have been very pleased to move forward with new positions. And these positions now are picked up by the universities now that the Canada First Research Excellence Fund will finish in 2 years' time. So,
you're at a coffee shop in Sudbury, and you're just in at Tim Hortons talking to a guy or a gal, perhaps, and they said to you, "What the heck do you do there?" And what is the significance to the Canadian public for what you do? I mean, I understand it, but there's a lot of tax dollars going into this, and I understand there's some great results. How would you describe it to Joe Public at Tim Hortons that's curious what goes on there and the benefit?
I would say, do you know how this universe we live in came about? Do you have a feeling for how it all started and how it developed to the point that we have the things we have around us? That's what we're studying. We're trying to, and we have this tremendous description of a Big Bang 13 billion years ago and the way in which things evolved to the present time. It's a understanding of our history at a very profound level. A level of how did everything start and get to be the way they are today for the whole world.
Thank you, Doc. Thank you, Dr. McDonald. Not easy to say that in 30 seconds. And thank you, Mr. Lobb. We will now go to Ms. Diab for 5 minutes, please.
Thank you very much, Madam Chair, and thank you so much to both of our witnesses. We're truly honored in this committee to have the caliber of witnesses that we're getting, and particularly on a topic that is, as Mr. Lobb indicated, I mean, it's a new one for many Canadians, and certainly us, and I think we're learning quite a bit, and which is part of what we're doing in this committee. Is that's why it was struck, and I think part of it is to increase our knowledge as parliamentarians so that we can better understand it ourselves and be able to make policies accordingly. Dr. McDonald, I read with interest some of your the fact that you actually hold a degree in physics from Dalhousie University. So I'm a Nova Scotian, and I went to Dalhousie myself, and so did all my kids, and they're all still there, I guess. And then you talked quite a bit about Snow Lab, which is fascinating. I think some of us on the committee might be looking forward to attending that facility, and maybe we'll see you there. You also talked about that Canada should be looking where it has natural advantage, and that we need recognition in the world, and I cannot agree more about that. Where else can you point us to? What else do you think, from your perspective, with with all of the experience that you have, what else should Canada be looking at, and where?
I'll answer you, but just of interest, one of my first summer jobs was working at the steam plant in Glace Bay that produced the steam for the reserves of Canadian heavy water that we used in the experiment. I'm from Sydney originally. I think Canada actually has a significant advantage in artificial intelligence and in quantum devices and quantum computing. Maybe in that sequence, quantum devices first, followed by quantum computing. I think Jeff Hinton and his colleagues in artificial intelligence have really made a major shift in the capability of artificial intelligence. I think that's an area that's very important to be supporting. In the healthcare area, I have been waiting for some time to see the effects of the fact that we learned about the human genome starting essentially in the year 2000. We now have an understanding of genetics. We also have the ability to diagnose quickly using genetics. I think we're going to have a revolution in medicine as we go forward. I think the ability to give what I talk to my colleagues, such as the head of the department at Queen's, and he tells me that what he's looking for is personalized medicine. That is, a way that you can attempt to tailor your treatment based on the genetic information you obtain and obtain quickly going forward. Those are a couple of areas I would target.
So, Dr. I hate to leave the questioning, but I have a colleague right here that's itching to get a question, and I'm going to let Mr. Pawlowski have the last 1 minute and a half.
Oh, quick. There's not a lot of time to ask this question, get a response, but what seems to me in this committee is very interesting is the extreme gap between what we're talking about and what you know and what we know. I have a bachelor's degree in biochemistry. I'm a medical doctor. I have no idea about what dark matter is about. I have no idea about what plasma is. And I can certainly understand the fundamental importance of this kind of knowledge in understanding the universe. I can also understand that this may lead to benefits ultimately in terms of medicine, energy, in various ways we can see a benefit from it. But are you frustrated with the fact that the people who know about the field of research and what is important, the gap between them and their ability to get the people who have the money, who make the policy, to understand the importance of this field and where the money should be going? I know there's people like NSERC and CFI who presumably have some expertise and can say we should be putting our money into this or that. But is that enough? And how can you talk to the people who ultimately have a source of money, which is us, and convince us that this is something we ought to be putting our money into?
Mr. Pawlowski, since that's the time, perhaps you would like to ask Dr. McDonald if he would give you a written answer on that.
You're what my wife refers to as a real doctor.
Thank you, everyone, for the good questions, the good discussion, our excellent witnesses. We will now go for the 2.5 minutes, and I believe it's Monsieur Guérin taking this as well.
Dr. McDonald.
Dr. McDonald, if you can do this in a minute, I'll give my colleague the courtesy of having you answer his question.
I'm very sorry, I'm not fast enough on the controls. Would you please repeat it?
If you're able to answer in less than 45 seconds now, I'll give you the courtesy to answer my colleague's question, if you can quickly, Dr. Pawlowski.
Oh, you're letting me respond to his question. Oh,
In 45 seconds.
That's correct.
45
It's
seconds.
30 now.
Well, fortunately, there's another McDonald named Bob who helps a lot in some of these things. But understandable what you say. I, of course, know very little about your expertise. I think peer review is a very important process in all of the decision-making that happens in Canada. And there's peer review at various levels. The peer review that happens for individuals with the granting councils is important. You also have to escalate that when you're trying to make your decisions on your moonshots. I also think, and at the time of the Fundamental Science Review, there is a recommendation of a major overview committee for the government with representatives of academia, industry together, giving an overall perspective for how science and technology should be carried out in this country, and a roadmap for that sort of thing. I think it would be of great advantage to your committee if such a committee of experts, coupled with government experts, were in fact in existence.
Dr. McDonald.
Dr. McDonald, I'll interrupt you, Madam Chair. If I can take those 30 seconds that I lost from the translation mishap there, I know you don't have to grant me this, but I'm not committing anyone to anything here by saying this, but would you have any examples of projects that would be global in scope that might be happening today in Canada or in Quebec that could be a moonshot, that could inspire us in our thought process?
There's one project that Chime is an example, not in Quebec, as it turns out, but Chime is an example that is asking for additional resources. They really have a new idea that came from Canada that really has a major effect in radio astronomy in terms of trying to understand that field.
Sorry to
So I don't have
interrupt.
other specifics.
Dr. McDonald, I have the worst job. I'm forever interrupting, and I'm sorry, Monsieur Guérin. Thank you. And now we will go to Mr. Cannings for 2.5 minutes, please.
Well, thank you. And I'm going to continue with Dr. McDonald because you mentioned the Human Genome Project, which I was going to bring up anyways, but you did it on your own. And personalized medicine. I know Peter Cullis at UBC has written a book on that subject. Things that have flowed from these moonshots, these big science projects. But as I understand it, that Human Genome Project involved a lot of cooperation and sharing of data. And my experience in the science world has been somewhat the opposite, where a lot of scientists, while they're doing their projects are very, until you publish, you don't share that. I'm just wondering if you have any sense that we have to change that paradigm of, and encourage more open collaboration, and these moonshots have to involve teams of scientists working together and sharing ideas and data throughout the project.
There's no doubt that these moonshots are of such a scale that Canada can't do it alone. There has to be international cooperation, and by its nature, these large international cooperations involve the sharing of data very freely within hundreds and hundreds of scientists. It's very important that data is not released before it has been properly assessed by the experts. And so you have to have the mechanisms whereby these opportunities for true experts in that field to come together and come to a conclusion, even if it's only preliminary and then can be helped by others. But it has to be a certain degree of internal work before you release it to the general public, or you won't have the peer review that you get on articles. That's very necessary as well. So I think all of these moonshots are of their nature international because they're of a scope that the particular topic is something that will be of interest across the world. But I should also point out that these major research projects also push technology right to the frontier. And so, there are things we're working on our projects right now that will result in improved detection devices that will, for example, reduce the dose you need to use in positron emission tomography. There are different areas, different things, but there are effects of pushing technology or even pushing companies to improve their technology that result in immediate and helpful new things.
Thank you. I think I'm out of time again.
I'm afraid you are, Mr. Cannings. Dear colleagues, seeing as we're at 7:29, it's my honor to thank both our witnesses. Dr. Russell, we're very grateful that you would join us from the States tonight, and we wish you good fortune, good wishes with your research. And Dr. McDonald, it's always lovely to see you, and we're grateful for both your expertise, your time, your effort. I hope you've had a good experience and that you will want to come back to our committee. So I know all of us are very grateful. And with that, we will suspend before we go to our next panel. Suspended. colleagues, I'd like to make a few comments for the benefit of our new witnesses, and we welcome them tonight. Please wait until I recognize you by name before speaking. For those participating by video conference, click on the microphone icon to activate your mic, and please mute yourself when you are not speaking. Interpretation for those on Zoom, you have the choice at the bottom of your screen of either floor, English, or French. For those in the room, you can use the earpiece and select the desired channel. A reminder that all comments should be addressed through the chair. I would now like to welcome our witnesses. Appearing as an individual is Dr. Banerjee, a research scientist and adjunct professor from the Vaccine and Infectious Disease Organization at the University of Saskatchewan. From the Stem Cell Network, we have Kate Murray, President and Chief Executive Officer, and Dr. Michael Rudnicki, the Scientific Director. Welcome. And from the University of Saskatchewan, we have Dr. Baljit Singh, Vice President of Research. We'd like to welcome all our witnesses. We're grateful that you would join us tonight. We're eager to hear from you. And each group will have 5 minutes to present. At the 4.5-minute mark, I will hold up this green card. It will let you know there's 30 seconds left, and I aim to be fair. So if you could wrap up after that time, it'd be much appreciated. So we will go to the testimony now, and we will begin with Dr. Banerjee. The floor is yours for 5 minutes.
Thank you, Madam Chair. Madam Chair and members of the committee, thank you for inviting me to this discussion. And the session is my first time, so I'm nervous and excited. I'm joining you from the Vaccine and Infectious Disease Organization. We are based at the University of Saskatchewan, which is situated on Treaty 6 territory and the homeland of the Métis. And I just had the privilege of coming back from the Royal Society of Canada's G7 One Health Research Summit at Lake Louise last week. And at the meeting, it became very clear that we need to focus on perhaps two things to protect the lives of Canadians from infectious diseases. First is to identify and address the drivers of emerging infectious diseases, and this includes a lot of factors, including climate change, land use change, and deforestation, and also to develop countermeasures and policies to protect human lives and lives of our livestock from emerging microbial threats. Now, if I may draw your attention to some statistics, greater than 70% of emerging infections have an animal origin. And we've only sampled and identified a fraction of microbes, including viruses, that exist in our wildlife. And we know even less about their potential to infect livestock species and humans. Even for pathogens that we do know exist and that those that can infect, vaccines and therapeutics remain unavailable. And some of these pathogens, unfortunately, have civilization devastating potential. If you look at Nipah virus, 40 to 70% mortality. So 40 to 75% of people that are infected are likely to die. MERS coronavirus, a very close relative of SARS-CoV-2 that we've all heard about, and it's a living reality for all of us. MERS-CoV can kill 35% of individuals it infects. And then you could always have the novel flu. And just as a reminder, the 1918 flu pandemic, Spanish flu, killed about 2.5 to 5% of the global population at the time. And multiple studies by my colleagues have now shown that anthropogenic factors, so activities that Homo sapiens or humans like doing, such as habitat loss and climate change, directly leads to animal migration, nutritional deficiencies in animals, which then directly impacts the pathogen spillover from these animals. So emerging infectious diseases pose a multifaceted, complex problem, which in my opinion will require, and perhaps some of my colleagues would agree, will require a multi-pronged and state-of-the-art and multidisciplinary approach with nationwide and international collaborations. And I hope that perhaps now we've got more appreciation of how quickly novel pathogens can emerge and impact humans, including fellow Canadians. And countermeasures remain unavailable largely due to lack of funding for pathogens that are not a problem yet. Prioritizing pathogens of importance and of threat will require AI modeling. So this is not just a health problem. We can also include quantum and modeling to identify risks, microbial risks for tomorrow. And while we need to build intelligence through modeling on emerging pathogens, we also need to test and archive vaccine and drug candidates that can be rapidly deployed in the event a pathogen emerges. For example, if you look at COVID-19, even with the fastest timeline in the history of vaccine development, we've still lost over 6.5 million lives globally, and these are only reported numbers globally, including over 47,000 fellow Canadians. So what I'm trying to pitch as an international moonshot program is the concept called One Health. It's a concept that recognizes the interconnectedness of human, animal, and environment health. And it's not a far-born idea. Sir William Osler, who was a Canadian physician and is perhaps considered by many the father of veterinary pathology in North America, had deep connections and interests in the linkages between human and veterinary medicine. And Sir William Osler went on to become one of the founding fathers of Johns Hopkins. So this is One Health was sort of born in Canada, and we're strategically positioned to lead this globally. So researchers in Canada have initiated globally competitive One Health research programs, including my laboratory that investigates zoonotic pathogens. But these programs it's scarcely funded. It's hard because we have to split up programs to fit the mandates of existing funding organizations. And I believe that we really have a unique opportunity in Canada to establish an internationally reputable, One Health-themed, inter- and multidisciplinary moonshot program that includes surveillance, quote-unquote, intelligence gathering, risk assessment, so you go to rank priority pathogens, and therapeutics and vaccine development and outbreak detection and mitigation policies. So we truly have an opportunity to lead the way in developing a holistic research program to prevent the next pandemic and the next emerging infection. I will stop with that. Thank you, Madam Chair.
Thank you, Dr. Banerjee, and I hope you feel comfortable. This is a group that is genuinely interested in learning from you, so we welcome you. We will now go to the Stem Cell Network for 5 minutes, please.
Madam Chair, I'm joined by the Stem Cell Network's Scientific Director, Dr. Michael Rudnicki, who's globally known for his work in muscle stem cells and regeneration. When people are asked to describe what technologies are needed to achieve a moonshot, they tend to reply with artificial intelligence and quantum computing and big data. It's not often that they'll consider the sophisticated technology that resides within the human body. I'm speaking directly about stem cells, the building blocks of each of us. Stem cells were first definitively discovered by two Canadians, James Till and Ernst McCulloch. Stem cell research is Canada's science, and we've been leading the way delivering game-changing discoveries and therapies that come from this human technology for the past 60 years. Stem cells can divide indefinitely, and they can make any cell in the body. They are one of nature's most ultimate innovations. It is the human body that presents us with the opportunity to achieve the greatest moonshot of all, the eradication of disease, of illness, and of injury. This idea may sound implausible to many, but moonshots, by definition, are meant to be ambitious, audacious, and grand. Stem cells are driving the field of regenerative medicine. To quote from the Council of Canadian Academies, the appeal of regenerative medicine is in its curative approach. It's about repairing, regenerating, and restoring function to cells, to tissues, and organs. It's already delivering advances for heart disease, Parkinson's, muscular dystrophy, type 1 diabetes, and even for COVID-19. Let me share a little story with you. Tyler Raby was an ambitious, athletic young man from Quebec. He had not yet celebrated his 25th birthday when he was first diagnosed with an aggressive form of leukemia, a cancer that defied all standard treatments. Within a year, he was confined to a hospital bed, facing a terminal diagnosis. His doctors worked to have him enrolled in a stem cell trial, clinical trial, funded by the Stem Cell Network and run by Dr. Sandra Cohen. Tyler received a stem cell transplant to generate enough stem cells They were expanded using a novel technology and a proprietary molecule called UM171, and they were optimized using a culture system. The treatment worked, and following months of careful recuperation, Tyler was able to return home where he met his godson, kissed his girlfriend, and returned to his studies. This innovative therapy is now being further tested across North America by a Canadian biotech called Excelthera. Regenerative medicine technology will also have critically important economic benefits as we move forward. Prior to the pandemic, the burden of chronic disease cost Canada $190 billion annually, with the direct cost accounting for 58% of annual health care spending. The costs have undoubtedly escalated. It's a trajectory that must be addressed. The good news? Investment is strong. Private investors are pouring billions into Canadian life science companies. In fact, in 2019 and 2020, the sector raised $2 billion in venture capital and $5 billion in public equity. But as we all know, investment in commercial success is predicated on world-class science. And that's where networks like ours come in. Canada's Stem Cell Network is comprised of leading researchers and trainees who are laser-focused on stem cell and regenerative medicine research. We partner with charities, with industry and governments to ensure the science we support is driving next-generation therapies. Stem cell research takes time. The research started today will result in the personalized medicines of tomorrow. We can envision a future where specific medicines for you will be made in the hospital where you're being cared for. Additionally, right now, specialized bioinks are being innovated and will be used for bioprinting of tissues that can be used to patch wounds and organ function. In time, we'll realize a future where treatments fit the patient rather than the patient having to fit the treatment.
Ms. Murray, I am sorry to interrupt. I am sure there will be good follow-up with you, and we're so grateful to we've had Dr. Banerjee, we've had you from the Stem Cell Network, and now we're going to go to the Vice President of Research at the University of Saskatchewan. Dr. Singh, the floor is yours.
Madam Chair and the honorable members of the committee, I am so honored to have this opportunity to be in front of you. When the question came, what could Canada's international moonshot be? I thought of many possibilities, but the one that struck close to my heart based on what Canada can offer to the world was this world which is well-fed, food secure, and where people who have enough food to give to their children can send their kids to school. And this is the world that Canada always envisions to be a peaceful world all around us. So my idea for the moonshot is a food secure world which is peaceful. The reason Canada is potentially the only country in the world who can deliver this moonshot is based on three fundamental ingredients of any moonshot if we are going to be thinking about that. It got to be inspirational. Canadians have been inspired by a vision for a world that is peaceful. We know that there cannot be peace without food security anywhere in the world. Canadians have made supreme sacrifices whenever called upon for the sake of peace and prosperity in this world. Therefore, Canadians can be inspired when it comes to feeding more than 8 billion people today around the globe. The second component of a moonshot is the credibility. Now, where does that credibility come that Canadians can think about delivering this outstanding international moonshot? First, we need large pieces of land that we can use in a sustainable way to grow food, whether it is of the plant origin or the animal origin. Second ingredient to grow the food is the water. Canada is endowed with abundant supply of the fresh water, which we are taking extreme precautions based on the science to make it sustainable over a long period of time. To fuel the production of plant-based food, we need fertilizers. Canada has abundance of fertilizers like potash. Yes, there is a need for us to transition away from heavy use of the fertilizers, and that's what Canadian innovation in the field of soil science, precision agriculture is leading us to. I believe with the right kind of investments, Canadian plant science people can deliver the type of varieties that can grow on the smaller amounts of precisely applied fertilizers, and we can grow the crops, develop the crops which can withstand climate change and global warming. The last piece is that Canadians have invested significantly in their cluster of academic institutions from coast to coast that have delivered innovation in all aspects of agriculture. That is the innovation that has made Canada's agri-food production sector to be envy of the world. And we have not only created prosperity and the new jobs in that sector, we have also exported the food which is affordable, which is nutritious, which is sustainably produced, and which actually carries the Canadian brand and makes us all very proud. And last piece is the investment during in the areas such as protein industry supercluster has brought academy and the private sectors together. The third ingredient of an international moonshot is imagination. That's where we need to come together as Canadians to be imaginative, to be collaborative, to bring ourselves together that this is the moonshot that we can deliver to create a food secure world with our efforts in this country. We need to pay attention to the sustainable development goals of the United Nations. We need to pay attention to the climate change that is occurring around us. We need to understand that large parts of this world are not in a position to produce enough food for their own population. So this, Madam Chair and the Honorable Committee members, is my idea for an international moonshot that Canada can deliver. Thank you so very much.
Thank you so much, Dr. Singh. And we're glad to have you back at committee. It's really lovely to see you. And to all our witnesses, we thank you for being here. We're looking forward to hearing more of your ideas. We're now going to hear from our members. You have a very interested committee, and this will be a 6-minute round. And tonight we begin with Mr. Soroka. The floor is yours.
Thank you, Madam Chair, and thank you to the witnesses for coming this evening. I have to admit stem cell research is very interesting to me, and I guess the first thing you always think about is cancer research. But, you know, as you explained, there's a whole much more to it. My first question is, though, with $2 billion from the private sector already being invested, are you having an issue getting funding, or do you still need to have funding available to you?
Well, the investment in these companies are the discoveries that are mature enough to be commercialized. What CIHR does is, of course, is fund the basic research, and we need that robust foundation of discovery. Organizations like the Stem Cell Network build multidisciplinary teams from across Canada to move that research along the pipeline through research and development, clinical testing, and bring it to the point where it can be commercialized. So we fund projects that are harebrained ideas that no one else will fund, like the project that led to the cure for the patient that Kate described, as a small catalyst grant, impact grant, move it along all the way through to larger teams doing the research and development, all the way through to clinical testing. We don't fund and forget. We manage these projects in live time. So we're very different from the funding councils.
To that, because there's so many different areas of regenerative medicine that you're dealing with, how do you prioritize who gets funding, who doesn't, and how do you issue that out?
Yeah, so, you know, stem cell research has paved the road for regenerative medicine to enter the clinic, and it's going to transform the practice and is transforming the practice of medicine. How we prioritize the research is through expert peer review. We actually bring in a lot of international reviewers to look at our projects, but we don't just evaluate the science. We evaluate the composition of the team. We evaluate the stakeholders that are involved and the training that they're doing, multiple aspects of the project. They have to tick the box for outstanding world-class science, and regenerative medicine research in Canada is internationally at the top end, but ultimately it's peer review.
With all the research that you're doing, are you finding that there's any barriers that you're having to come across, such as either policies or programs or something that the government has initiated? Is there something that you're having struggles with that you need help with?
Well, there's probably a list. Certainly the funding cycles that we faced have made it difficult to roll out support on an annual basis. That's been an ongoing problem. There's issues around regulatory issues at Health Canada that we're working with all the stakeholders and Health Canada to help move that along. We would like to enhance the commercialization of some of our discoveries, but because of our funding agreement, we can't support research in companies. These are very small companies. We have to support the academic aspects. What else?
Immigration?
Yes. Well, attracting people to work in labs and in projects is becoming an increasingly difficult problem. So, for example, I had a student who I was trying to bring in recently, and it took 6 months to get his visa approved. He almost decided to go elsewhere where it was taking a lot less time. So those sorts of backlogs are making it very, very difficult to bring in people, and it's harder and harder to find people to work in labs.
Actually, that's quite an interesting thing, because you had said it's stem cells such a success in Canada. I was really thinking you'd have no problems retaining researchers here, keeping Canadian jobs or Canadians researchers right in Canada, but you're already asking to bring in from other countries. Is this still sustainable that we have Canadians, or we do need a lot of more researchers from around the world?
An area of international strength, and many Canadians have gone through our training programs. And actually, in our study that we conducted internally, because of our community and the network that we've built, they tend to stay in Canada. So the retention rate is very high. But because we are at the top tier of research, we attract many, many people from abroad. And I have a postdoctoral fellow who did his PhD in the U.S., originally from Sri Lanka, who is applied for his permanent residency. He wants to stay in Canada, and he's an outstanding scientist. And I've had many other trainees stay in Canada and get positions at universities or work in companies and so on. He's still waiting to hear about his permanent residency. It's really slow these days. But this is a real win-win-win for Canada when these people decide to stay and make Canada their home.
Well, that's good to hear, because a lot of times we hear that most are leaving Canada to go to other places. So if they're able to stay here, I see I'm getting the green card. My question then to you is, Ms. Murray, you had spoke about how stem cell can almost cure everything. Like, as the moonshot, is this the ultimate goal, that stem cells will be able to basically even regenerate limbs? Is that a potential, and do you think it can cure everything?
Stem cells have significant potential to treat all sorts of chronic disease, rare disease, illness.
Could I rudely interrupt, Ms. Murray? Because Mr. Soroka's time is up. Mr. Soroka, perhaps you'd like to ask Ms. Murray for a written answer there.
Yes, I'd prefer then a written answer to that as well. Thank you.
Thank you so much, Mr. Soroka. And again, we're very grateful to our witnesses. We will now go to Monsieur Lauzon for 6 minutes, please.
Oui, bonjour à tous.
Good day, everyone.
So I will ask my question in French. Merci.
Thank you for being here today. Very interesting. You've piqued my curiosity in a range of subjects. I think I had a whole host of questions I wanted to ask, and now I have a whole host of other questions. Dr. Banerjee, you referred in depth about infectious diseases. I myself, in my writing, heard about a number of zoonotic diseases. Thousands of animals had to be culled because there was no way through science to prove which animal had been infected. You talked about extrinsic factors, for instance, that some animals like bats could spread these diseases. In link with your research, would artificial intelligence be useful if we had more detail as to the situation I was referring to in my writing?
Thank you for the question. That's a fascinating question, and in fact, there is data as of last week for this. So this is very timely. So my colleague, Dr. Raina Plowright at Cornell, just published a 25-year longitudinal study identifying factors that directly impact pathogen shedding from wildlife species, such as bats. And they identified migration patterns and nutrition deficiencies in wildlife that triggers pathogen spillover from these animals. So I think, yes, so modeling could predict, but zoonotic transmission they're very nimble events. They're very rare events, and a whole bunch of stuff have to align for the perfect storm for a pathogen to make it into humans. And again, there's a whole body of studies that look at how successful transmission events happen from animals into humans. But yes, I think modeling, data-driven modeling, is certainly a good place to start, where you can imagine the diversity of mammals on this planet. Where would you sample? What would you prioritize? But I think having that surveillance and having that modeling to estimate certain focus points for sampling and monitoring, I think would be a very good place to start.
Merci.
Thank you. Do you use that kind of situation, for instance, where there's an event like that, do you use that data to advance your research? And as a government, how could we be helpful? How could these projects become larger in a way?
And there are very good surveillance programs in the US, and not just within the US, but American colleagues who are surveilling across and overseas. So I think what we really lack in Canada, and this is through conversations with my colleagues in Canada, we really don't do surveillance. We don't have a good surveillance model for our own country, and we have very little in terms of surveillance for threats overseas that may come on an airplane into our country. And zoonotic events are not restricted to Canada. These events could happen anywhere on the planet, and if it gets on a plane in less than 24 hours, that pathogen could likely show up in our borders in Canada. So I think, yes, having some sort of a program that'll complement, and I was listening into the previous committee as well, how moonshots could potentially be international with collaborations for zoonotic pathogens and for emerging infectious diseases. We absolutely need to work with our colleagues overseas. There's no way we can go in and start sampling in countries overseas without collaboration from colleagues in that country. And data sharing is another critical aspect of that as well. If we're trying to identify pathogens, why would somebody want us to surveil their country if that pathogen would have trade implications for them? For example, a rinderpest in livestock. So that's something we need to be cognizant of. I always use this in the classes I teach, is empathy for when we are designing these studies, and perhaps also identify what is mutually beneficial, not identify threats, but propose solutions.
Thank you. Thank you for the answer.
Thank you.
La question pour ces...
Mr. Singh, I have a question for you. You were really quite inspiring to me. You talked about credibility, inspiration, imagination, all of this to serve as a basis for these major projects. You referred to agriculture and how we can improve the system. Our government, Mr. Singh, recently created living labs with our producers. Our producers themselves will be doing the research on our lands for reducing fertilizer, nitrogen capture, and other derivatives, other ways of improving health through the way we produce goods. On the basis of your testimony, do you think there could be more programs to look at agriculture in a different way with government assistance?
Thank you very much. The answer is yes. There could be other ways, and the most critical way would be integrating our system and aligning it with the moonshot idea. Right now, we have quite a bit of fragmentation of our ecosystem coast to coast. So that's where the imagination part comes in to bring it all together. I think my time is up. So I'm happy to send a written note to the honorable member, please, if he so desires.
Thank you so much.
Yes, Madam Chair, if it'd be possible to get further detail on that point, I'd much appreciate it. Thank you.
Thank you, Monsieur Lauzon, and thank you to Dr. Singh for the kind offer. We will now go to Monsieur Blanchet-Jonca for 6 minutes.
Bonsoir, Madame.
Good evening, Madam Chair. It's a pleasure to have you here again, to see you for the second hour of our committee. Mr. Banerjee, you know, COVID-19 drastically changed the way we do things when it comes to funding, research, cooperation, communication in the scientific field. Can you indicate how things have changed for you?
Thank you for the question. I think I'll take a couple of years steps back. And when COVID-19 showed up, we were one of the first to mobilize. At the time, I was at McMaster University and the University of Toronto. And I think the biggest challenge we faced at the time was personnel. We had no personnel capacity in Canada to work with risk group 3 pathogens. So when we were planning on isolating the virus and using it to develop therapeutics and vaccines, the first thing we had to do was, start training people. And I was fortunate and very lucky that I'd done my PhD on coronaviruses, high pathogenic coronaviruses. So we were able to go and mobilize people and train teams of experts who could start working with SARS-2. I think what's been very fascinating was the amount of collaborations that came out of this. I really think the virology community in Canada and my colleagues that work across disciplines, everybody stepped up. Everybody came through. We worked hours and nights to get this virus out, share it with colleagues who were studying it, help with vaccine development studies. So I'm a naturalized citizen, so I'm an immigrant in Canada, and I was extremely impressed by the hard work that my colleagues across disciplines in Canada put in to study this virus and understand this virus. So I was very moved, but at the same time, I was also very, very frustrated that while we were studying the virus, we were also writing research grants. What I didn't understand was why couldn't the money come in to help us identify this pandemic causing, at the time it was called novel coronavirus. But we and my colleagues were all writing grants to keep funding the studies that we were doing to help Canadians and the global population. So what for me is very refreshing is seeing all this major infrastructure investments by the Canadian government to facilitate studies into, studies that require high containment facilities. But at the same time, a part of me is I worry a little bit. Will this funding be sustainable? Because if we don't continue to train our trainees, so I work in a high containment lab, it takes us 3 to 4 months to train someone so they're competent to work by themselves. And each time they graduate or they leave because the program's been defunded, it's going to take us 3 to 6 months again to train someone. And God forbid a new pathogen shows up, that's just too late. So I'm very worried about long-term sustainable funding, and that would be great to keep Canada at the peak performance for high-risk pathogens.
Merci.
Thank you very much, Mr. Banerjee. You refer to funding, that's really the crux of the issue. I'd like to hear what you think about Canada being the only country in the G7 that has not managed to produce a COVID-19 vaccine internally, domestically.
So I think this challenge has been widely acknowledged that we didn't have biomanufacturing capacity in Canada. And it's for me, it's very refreshing to see that we are making those investments. We may not be as impactful for COVID-19, but who knows if COVID-19 it is probably on its way to becoming endemic, and we may need seasonal shots. Perhaps it's not too late for us to develop homemade vaccines to continue with the booster programs moving on. And hopefully the industries will stay. We at VIDO are fortunate to have received funding for vaccine manufacturing facility. So I think this has been a huge learning step for us, and hopefully we continue to build on it and not lose momentum.
Mr. Banerjee, you referred to recurring funding and support. You say it's crucial for research and development. Based on your experience, what are the consequences of the disinvestment in science and research in Canada? I think the facts speak for themselves, Canada being the only G7 country that reduced its investments in R&D over the last 20 years. I'd like you to translate that into concrete terms. What are the actual effects that you're seeing of these decisions?
So my colleague previously alluded to was loss of trainees, and I really believe in curiosity-driven science. I'm part of Let's Talk Science. I talk to school kids, and you see the spark in their eyes. Children by nature are extremely curious. Our kids are very curious. If you take away the ability for them to live on with their curiosity, you're like, what would you do? Like, I can't imagine my life in a country or in a world where I can't be curious. So I think that's what science enables us to do. We can retain our curiosity. And you wanted some metrics. So, loss of trainees. The more we lose trainees, we are losing not just, I can only speak to virology, I'm a virologist by training, but every facet of science is dependent on the next generation of scientists. I only recently transitioned from a postdoc to having my own lab, so I really know how difficult it is to be a postdoc with the salary that we pay our postdocs in Canada. So I try and make every effort to pay them a livable wage so they continue to do their postdocs and they see science as a career that's financially and in terms of having a family life is possible. So that's what I'm trying to create within my lab.
Merci beaucoup.
Thank you very much. Given the data we've just heard, I'd like to hear about what you think the federal government's priorities should be when it comes to Moonshot. You referred to funding. I also shared the data that we currently have. I'm trying to understand what exactly should be the federal government's priorities. Should it focus on new structures, new programs?
Shankar, I'm sorry, that's your 6 minutes. If you would like to ask Dr. Banerjee for a written question, if you so choose.
On va demander une question écrite, madame.
Yes, please, Madam Chair. Thank you.
Thank you so much, Monsieur Blanchet-Shankar. And now we will go to Mr. Cannings. And just let me say thank you again to all our witnesses. You're very gracious. We appreciate your time and expertise. And now we will go to Mr. Cannings for 6 minutes, please.
Well, thank you. And again, thank you to all the witnesses here. And I'll continue with Dr. Banerjee, especially because I see proudly displayed behind you a book on bats by my friend Brock Fenton and others. And it just brings up this, you talked briefly about monitoring. I'm a bird biologist and once actually had funding from a health agency to monitor birds for West Nile virus for one season, and it helped us immensely in our work. We were just trying to calculate bird population trends. But as soon as we discovered there was very little West Nile virus in the bird population, they seemed to lose interest. But I'm just, perhaps my question really is, these moonshot programs are, by their nature, very collaborative, big projects that involve different scientists from different aspects. And I'm just wondering how you would see something like your project, One Health, organized. Is it international? Is it Canadian? And how do you see the organization and the funding of it flowing?
Thank you for the question. Excellent question. This is something we do have an application in on the New Frontiers program, the transformation stream, which is about 24 million, I think. So it's a big enough program, but it's also extremely competitive, and the program only funds about 6 grants. So my take on One Health comes from an infectious disease perspective, because that's my bias. But we also are cognizant of the idea that infectious diseases also depend on climate change and animal health and human health and the environment health in general. So this program, if I were to propose this, would certainly be an international program. We can't do world-class science in silos, but Canada does have an opportunity to lead it. We've got all the ingredients in Canada to lead an international moonshot program, starting from surveillance, what I've perhaps tried to call intelligence gathering, risk assessment. We've got colleagues who are exceptional at modeling and identifying which pathogens are likely to be the next epidemic/pandemic. Therapeutics and vaccine development. With Canada's infrastructure investment through BRIFs and CBRIFs, we've got capacity in Canada to develop vaccines and therapeutics and test them. And finally, through colleagues who are very good at developing policies, we can come up with outbreak mitigation policies. So an international One Health program led by Canada, but something that is globally impactful, is what I would see as a moonshot program.
Well, thank you. And I just also wanted to pick up on something that Monsieur Blanchet-Jonca was mentioning, and you were commenting on as well, is just the support, the basic support for the people in science, especially the students. We've heard before this committee and other studies the fact that master's programs, PhD programs, the scholarships funded by the tri-councils, those amounts haven't gone up since 2003. Postdoctoral fellows are a little better off, but we need to increase the amounts of those and the numbers. And just to keep students here in Canada so that they can be there for these moonshots and other things. I'm just wondering if you could comment on the value of that for this government to make those investments.
I fully agree. So I'll give you an example of a postdoctoral fellow in my lab who was considering moving to the US because they have a K-99 fellowship program where you get funding, which is a much higher salary fund, but you also get investments to kickstart your own lab. So in some ways, the government is investing in the top talents to stay in that country. And I'm very glad that CIHR has now come with a targeted fund that's very similar to the K-99 program, but it's still not as broad and wide as we would expect in Canada. Most colleagues of mine, most postdoctoral friends of mine go to Boston or go to the US for a postdoc, and they find jobs. So why can't we keep them in Canada, offer them competitive salaries so they can kickstart their own laboratories and chase blue sky science? I think there is absolute merit to doing that and keeping our trainees here in Canada. I fully agree.
Thank you. And I just want to turn to Ms. Murray and Dr. Rudnicki to comment on that as well. I mean, you're coming from perhaps a slightly different space, but maybe.
Yeah, so, I mean, I've had students tell me that they're going to write up their master's and not pursue a PhD because they can't afford to live. I mean, this is an equity issue. If you don't have parents helping you, you can't pursue a graduate degree. And postdoctoral fellows being paid, you know, the approved pay from CIHR is $42,000 a year. Well, if you're got little kids at home and trying to make rent, you can't live on that in Toronto. And it's hard enough to live, it's very hard in Ottawa. Both spouses have to work, but they're living in a tiny apartment and don't have a car, and, you know, it's very hard to live. And so people are leaving.
And it's $17,500 and $21,000 for masters
Correct.
And PhD students.
Yes, below minimum wage.
Yeah. Do I have much time, Madam Chair? I have to look in some other. You're not on the screen in front of me.
20 seconds.
Oh, okay.
20 seconds.
I'll cede my time. Thanks.
You're always so gracious, Mr. Cannings. Thank you for that. We will now go to the 5-minute round, and this time we go to Mr. Mazier. The floor is yours.
Thank you, Chair, and thank you for the witnesses for coming out this evening. This is going to be for all of you, and you'll all get a chance to answer this question. But according to a report released by Vancouver Public Library's Skilled Immigrant Information Center, 33% of biotechnology and life sciences employers in Canada are reporting skills shortages, and 20% have job vacancy in their companies. How significant is the skilled labor shortage in the Canadian biotechnology industry? And we'll start here in the...
It's huge. It's huge. I mean, we're working very hard to address that with our training programs, and we know from talking with companies like Stem Cell Technologies that without our programs, they would have a hard time meeting their needs. So we need training. We need a full slate of students and postdoctoral fellows coming up. But this is true across the sector. People are not going into STEM because they think that it's not a way to pay their bills.
Dr. Singh? Want to take it? No? Okay, we'll ask another set. When referring to potential solutions to address the skilled labor shortage in Canada, the president of Biotech Canada, Andrew Casey, stated, and I quote, "I think you've got to look at a suite of things that may influence someone's decision, like a school system, the immigration policy, the tax policy. Do you think that if Canada recognized foreign credentials more quickly, we could attract more skilled labor from around the world?"
I think we have to have accelerated certification programs. Often some from... Well, a lot of the professional, I'm thinking for medical doctors and nurses, nurses can't even, they have to write an exam in every province. That's kind of ridiculous. It should be a national certification. And barriers are put up. If you're a vet from Afghanistan, you may have a hard time getting into a vet school, so you can spend a few years getting certified. That kind of thing. For PhDs, it's a lot easier. You find a lab that'll host you as a postdoctoral fellow, and so on, and away you go. You get your Canadian credentials, or get your degree here. For foreign faculty, that's very difficult for them to get jobs here in Canada doing research and teaching at a university for whatever reason.
Okay, very good. Dr. Singh or Dr. Bandry, anything to offer?
Thank you very much. The shortage of skilled professionals is occurring across all sectors. In my role as vice president, I hear from the private sector all the time. There are some mechanisms that we can ramp up in our country. For example, one of the Tri-Council funds a training program called CREATE program, which is a 6-year-long funding. Dr. Banerjee is a graduate of that program. We brought him from Germany to come to Canada to do a PhD, then stay here. And we could also, within that program, create a bridging program for the new Canadians whom we bring here, but sometimes we do not connect them to the meaningful training opportunities and their entry into the workforce. So I think we as a magnet for immigrants, if we could do that last piece of integration, we might have a pretty steady supply of the workforce into all of our sectors. Thank you.
And
Madam Chair, if I...
Sure. Okay, go ahead.
We're just going to add very quickly that perhaps in graduate studies, your future is not very predictable. And that's what perhaps affects the ability for students to come and join a graduate program. When you go to a trade course, your future is predictable. You want to do this, you want to be a mechanic, and this is how much money you're going to make. But you come into graduate school and then everything's a big question mark at the end of it. So how do we convince our future students to come and join graduate school?
And Dr. Singh, I guess I wanted to expand a little bit more what my colleague Mr. Luzon was talking about ag and an ag moonshot program. I think it's near and dear to my heart, I know. And how would you, in 20 seconds, expand on that a little bit more? What would that look like, especially in here in Canada and working with on a North American type of approach?
What I can state is that is one moonshot idea for which we have literally every ingredient in place in our country. That goes from the supply chain systems to the innovation, to the artificial intelligence, to quantum, to public policy frameworks, to really the land and the water and the energy. The question is, can we have whole of the country saying what people used to say in the 60s, it doesn't matter who was working on the project and where the person would say, I am putting a man on the moon. Can we as Canadians really think about that? I am feeding the world.
Thank you, Dr. Singh. That was really good of you to keep that so tight. Thank you, Mr. Mazier. And now we'll go to Ms. Bradford for 5 minutes, please.
Thank you, Madam Chair, and thank you so much to all of our witnesses tonight. It's been a very educational and fascinating evening so far. I had the benefit of attending the Sprott Center at Ottawa General last week, actually, their center where they focus on regenerative medicine. So I'm so happy that you both were able to join us in person tonight. And Ms. Murray, your opening remarks were very inspiring and compelling, I think, for all of us. And I just wanted to point out that while I was there, it felt like the United Nations. There were so many, it seemed that just about all of the students were international and had come from somewhere else. And I think because of the excellent work that you're doing there and your reputation, Dr. Rudnicki, that they want to be here and they want to stay. So, and I certainly hear about the struggles and frustrations with the immigration and the visa process to make that happen. So I was wondering, we all know that it takes time to bring these therapies and technologies to market. Can you tell us what the Stem Cell Network plans to do over the coming decade to ensure that the research will be translated and benefit patients?
Happy to take that. The Stem Cell Network is about following the research and supporting it as it develops. Clinical trials are a key piece of work that the Stem Cell Network invests in. And so we fund early phase 1 and phase 2 clinical trials. And we support companies through research projects to ensure that those companies that are at the preclinical or clinical stage can develop the data and the validation materials that they need and packages they need to bring investors in on their projects. This is absolutely critical at the translational space. It's not widely done. And by organizations or networks like ours, and it's absolutely essential for moving research forward. And in fact, 2 of our projects that we have been working on and programs we've been working on over the years in type 1 diabetes and for premature infants with underdeveloped lungs will now be launching into clinical trials in December. These will be world firsts for Canada. So that's how we're moving things forward.
That's very exciting. Thank you for that. Now, we always get down to the affordability aspect when we talk about healthcare. So the affordability of cell and gene therapies are known to be very expensive because they're customized to the patient. And some would suggest that they could bankrupt our healthcare system. What, in your estimation, needs to be done so that they can effectively be integrated into a cost-effective manner?
Great question. Access, affordability, cost structures. This is a major conversation for this country to have and for policymakers such as you to be informed and thinking about. Cell and gene therapies will be revolutionary for our healthcare system. And the way that we think about them, where the costs will come up front rather than over a lifetime, is different than how our healthcare system thinks about these drugs and these therapies at this point. So we need to reconceptualize that. We need to understand the values that Canadians have around cell gene therapies and how to adopt them. We need to think about the tools that decision makers need to be able to make decisions around what will be adopted by our healthcare system. This will take a number of years and all sorts of different voices at the table, from industry to academia, from regulators. The Stem Cell Network in our next strategic plan is proposing to do exactly that, to bring those parties together so that by the time we get to 2030, we've got the path forward in place so we know how to think about access and affordability. The science is going to come. It's up to governments and the rest of us to think about how we make sure these technologies get adopted and not lost to others.
Speaking of others, there seems to be a lot of interest in traveling to locations outside of Canada for stem cell treatments. Why do Canadians need to go outside of the country to locations like Mexico? And is it safe for them to do so? And she's flashing a card, so if you can be tight on that, or...
Well, stem cell tourism, and if it sounds
Yes.
too good to be true, it's often too good to be true.
Right.
These can be very dangerous. Some of these patients have died sprouted tumors and had other adverse effects. This is an area of active study for many years in Canada, led by the Stem Cell Network. We're internationally known for this type of research and dissemination of the dangers of these sorts of clinics.
Thank you. Well, I think the regulation we all
you.
know in Mexico is not the same as here. So thank you very much.
Thank you, Dr. Rudnicki, and thank you, Ms. Bradford. Unfortunately, we've come to the end of our time for this panel. I want to thank all our witnesses. Thank you for your testimony. Thank you for your answers. Thank you for your expertise. You've given the committee a lot to think about, and we hope it's been a good experience and that we will continue to see you at the committee. So we will say thank you, and we will briefly suspend before our third panel. Thank you all. Thank you. Suspended. Thank you, colleagues. And I'd like to welcome our witnesses. I would like to make a few comments for the benefit of the new witnesses. Please wait until I recognize you by name before speaking. For those participating by video conference, click on the microphone icon to activate your mic, and please mute yourself when you are not speaking. Interpretation for those on Zoom, you have the choice at the bottom of your screen of either floor, English, or French. For those in the room, you can use the earpiece and select the desired channel. A reminder that all comments should be addressed through the chair. I'd now like to welcome our witnesses, and we're delighted to have from General Fusion, Amy Barber, Director, Government Relations and Business Development, and from the University Health Network, Dr. Kevin Smith, the President and Chief Executive Officer. We're grateful for both of you joining us, and we're eager to hear from you. You will each have 5 minutes to present. At the 4.5-minute mark, I will hold up this green card. It lets you know you have 30 seconds to finish. And with that, we will now go to the testimony. And Dr. Smith, we will begin with you. The floor is yours.
Thank you, Madam Chair. Pleasure to be back with your committee. My name is Kevin Smith. As the chair said, I work at University Health Network and have the good fortune to work with over 1,000 researchers and literally thousands of research staff. I'm here this evening to enthusiastically support moonshot opportunities. We have great infrastructure in Canada, thanks to investment. We have great science in Canada, and we have remarkably talented scientists. So the question before us is, how do we harness that talent and potential to solve the world's most pressing problems and provide answers to Canadians and policymakers? I'd like to commend to the committee the Moonshot program work done by Brookfield Institute and just quickly identify 5 policy recommendations that the Institute made for successful moonshots. Define a clear grand challenge anchored in unaddressed real-world needs. Facilitate policy innovation by giving delivery agencies lean, agile, and independent governance structures. Create a portfolio of moonshot projects that are truly cross-disciplinary, cross-sectoral, inclusive, and embrace a range of different risk levels. 4th, support the full innovation continuum and the value chain from invention and basic science right through to manufacturing and commercialization. And last but certainly not least, 5th, focus on clear central metrics that matter to the success of the grand challenge, and in this case, show value to Canadians. In 2019, we saw an important moonshot innovation publication called Wishful Thinking, or Business as Usual, and it truly helps us understand that moonshots are about imagining a desired world that we may never eventuate. I'll take us back to President Kennedy, who in 1961 mentioned that we will go to the moon, take a man to the moon or a person to the moon in today's language, and before the end of the decade. 8 years later, that was achieved. Few of us would have believed that the microcomputer revolution that came out of that literal moonshot would have occurred, but that has truly and fundamentally changed our economy, our quality of life, our scientific integrity, and literally every facet of human society. Think of a world without microcomputing if that moonshot had not been undertaken. The investment in discovery research fueled an explosion in microcomputing and other important endeavors, and I hope the same will become true should the Government of Canada pursue a moonshot. Advances like these have created unprecedented opportunity to address society's most important challenges. Realizing these opportunities, of course, requires selection, development, targeted investments in breakthrough technologies, and focused on delivering rapid and transformative change. At UHN, we envision a national strategy set in large part by your group as the path forward to meaningfully advancing areas in this work. A national strategy would provide the necessary structure to select, enable, and deliver on key areas of focus where Canada can and should lead. This is already happening in many other areas around the world, and Canada is badly needed, and it is also badly needed for Canada. I would recommend to you a number of areas that immediately come to mind for my colleagues and I at University Health Network. The one we talk about most frequently, a sustainable, universally accessible healthcare system that is adequately staffed, the one before us each and every day. A moonshot that truly focuses on what is likely to be our next pandemic, antimicrobial resistance. An opportunity to partner with our United States colleagues where we do so much work together in science and truly conquer cancer in our lifetime. Last but certainly not least, a moonshot that really deals with brain disease and the scourge of dementia, which is affecting so many Canadians. And if I could, I'd also encourage in that moonshot thinking, understanding the basic science theme of inflammation spans almost every major chronic disease, and reinforcing that moonshots that are rooted in basic science bear the most fruit of all. In my mind, the opportunity is to look at a structure that once existed in Canada, the early days of the Canada Foundation of Innovation, which I had the privilege of chairing for a period of time, shows us a structure that can be extremely helpful to us. This would be separate from and discrete from the importance of the tri-councils in CFI, which can and should continue to focus on funding investigator-driven and appropriate research questions. I saw the green book go up, Madam Chair, so I'll wrap up by saying we at UHN are enthusiastic about the opportunities to champion moonshots that will affect all Canadians and indeed all citizens of the world. It will enable the best of Canada to collectively focus and to bring the greatest challenges of our generation to resolution. Thank you for the opportunity to address your committee.
Thank you so much, Dr. Smith, and I hope the committee will not mind me saying this. I'd like to thank you for your work over the last 2 years, particularly your life-saving work from you and your colleagues. So thank you for your testimony. And now I'm delighted that we will hear from Ms. Barber, who is the Director for Government Relations and Business Development from General Fusion. The floor is yours.
Thank you, Madam Chair. Thank you all for having me this evening. It's an honor to be able to discuss a visionary moonshot program with an all-party committee, and I appreciate your time so late in the evening. The problem General Fusion seeks to solve is environmental. Our technology will produce electricity with zero emissions. By 2050, there will be a 265% increase in global electricity demand, and in that same year, 33 countries have pledged to reach net zero in electricity production, including Canada. Although progress has been made introducing decarbonization strategies, the International Energy Agency reports that 50% of the reductions will likely come from technologies that have yet to be commercialized. Although this makes sense, we haven't had a new clean energy source introduced to the grid in a very long time. A Canadian moonshot program should focus on bringing new energy sources forward, like fusion. Fusion is the energy that powers the stars when two hydrogen atoms fuse and release a neutron and helium. To harness that energy, we need to replicate the conditions of the sun on Earth to achieve net energy. There are primarily 4 reasons why fusion energy is hailed as the holy grail of energy. The first is that the fusion fuel is abundant and energy dense. Fuel is extracted from seawater. 1 kilogram of fuel is equivalent to 10,000 tons of coal. Fusion is also carbon-free. There are no harmful atmospheric emissions from the fusion process. Fusion can provide utility-scale energy on demand as well, making an excellent complement to renewables and to battery storage. Fusion energy is also low risk. Fusion is the opposite of fission in many ways and has a risk profile that is akin to medical isotopes and is both well understood and regulated. It does not use special nuclear material, does not have long-lived radioactive waste, and does not have risk for criticality accidents. Because of these benefits, our company, General Fusion, has been pursuing fusion energy since 2002. Since then, we've secured over $300 million and currently employ over 200 people in Vancouver and have over 150 patents. Here's how our technology works, and I'm not a technical expert, but we inject magnetized hydrogen plasma into a steel vessel that is coated with liquid lithium metal via centrifugal force. From there, high-powered pistons compress the liquid metal around the plasma into a perfect sphere, creating high temperatures and pressure. At that point, fusion occurs. Our real game changer and our competitive advantage compared to many of the other players is our proprietary liquid metal liner. This allows for the machine to be protected from spin-off neutrons. At the same time, those neutrons interact with the liquid metal wall and produce tritium, which is in essence producing our own fuel supply. And third, the hot liquid metal is then run through a heat exchanger and produces electricity. Lastly, our use of mechanical compression with this liquid metal wall avoids the need for expensive magnets and high-powered lasers to sustain the fusion process. This results in a cost of electricity that is equivalent to coal. Over the past 20 years, we've proven the core components of our system, and we're now at the stage to assemble these together into our fusion demonstration program. In partnership with the UKAEA, we will build a prototype plant that will be 70% of scale of a commercial plant and located next to the record-breaking Joint European Torus at the Column Science for Fusion. At the same time we build this plant, our Brain Trust in Canada will be remaining busy building out the commercial maturation program. Our objective is putting energy on the grid by 2030, and within the past 2 years, a significant number of factors have converged that will make us very
Madame la
confident
Présidente.
in this timeline.
Madam Chair, we've lost the translation.
To interrupt, Ms. Barber. Yes, Monsieur Blanchet-Jonca.
Oui, il n'y a plus.
We've lost the translation for a few seconds now.
Thank you so much, Monsieur Blanchet-Jonca. Could we try to see if we've got translation now, please? Ms. Barber, would you like to try talking to see if
Sure.
we've got translation, please?
Parfait. C'est bien, c'est réglé, Madame la Présidente. Merci.
It looks to be settled. Thank you.
Thank you. So in the past couple of years, a significant number of factors have converged, which makes us confident that we can achieve net energy by 2030 and on the grid. First, and the fusion industry in whole. First, a significant private investment has increased 163% in the fusion industry in the past 2 years, and 40 companies are now competing in the race. National governments are also following suit with their public investment. The U.S. government spends the most with $600 to $700 million U.S. per year, and the Inflation Reduction Act is to authorize $280 million as well for fusion energy. Similarly, the UK has invested £400 million. The Canadian government's investment lags far behind. The existing grant programs have been critical to our success so far, but they are not sufficient to sustain the type of growth for the commercial scale that we are at and the stage in our development. For this reason, we've put a request before the Canadian government for $250 million over 5 years in exchange for warrants from which the government can make a direct return on its investment, proportionate in many ways to the private investment, and a commitment for us to maintain our headquarters in Canada. A Canadian moonshot program that directly invests in general fusion would leverage private sector investment, position the Canadian government as an equity partner.
Ms. Barber, I'm sorry to interrupt. You're very gracious. Thank you. You have a very interested committee. They will follow up with questions. I'd like to thank both you, Ms. Barber, and Dr. Smith for joining us. And with that, we will go to our first round of questions. They are for 6 minutes, and we begin with Mr. Masier tonight. The floor is yours.
Thank you, Chair. Is it Dr. Barber or Ms. Barber?
Yeah.
Doctor? Okay.
Is it Dr. Barber?
I
My
do.
apologies. Dr. Barber, my
Thank you.
apologies. My heartfelt apologies.
There you go.
Thank you, Mr. Masier.
I get a restart, right?
Absolutely you do. And a huge thanks.
So my questions are for you tonight, Dr. Barber. I've read some articles on fusion technology with investment in the United States. It seems there's quite a bit of private money going into the U.S. economy. Commonwealth Fusion Systems announced it has more than $1.8 billion in funding to commercialize fusion energy. Helion Energy secured $500 million for fusion technology, with another $1.7 billion waiting. TAE Technologies has raised $250 million in the latest funding from investors like Chevron and Google. So why is most of the private investment into fusion technology going into the United States instead of Canada? And how can we attract more investment here?
Actually attracted a significant amount of investment into our company. We are one of the 7 of the 40 companies that has obtained over 200 million US. So we are the only Canadian horse in the race. I do believe that we can attract more funding by demonstrating at-home support, being government funding and sustained continued patient capital. Some of the questions we receive from investors is where and to what extent is your government support and how is the government at the table? I think that would definitely incentivize. I also believe that we need to strengthen, and particularly to this committee, our investment in the academic institutions that are pursuing fusion. We've received over 17 letters of support for a recent fusion, or for a recent budget proposal from academic institutions that are extremely excited to build out their fusion capabilities and the unique challenges and spin-off effects that it would produce for the economy. So I think a commitment to see and to build talent at home would definitely also attract international investment.
The 2022 Fusion Industries Association's report noted that out of 33 private fusion technology companies in the world, 21 were in the United States. Only one, your company, was located here in Canada. So the Americans don't have a carbon tax, but they have a lot more money flowing into their country for this clean technology. Why is this?
In terms of public or private investment?
Well, private.
Private. I do believe we are attracting quite a bit of attention. I do believe proportionately. Again, I think it comes down to the public sector endorsement of fusion energy. The White House in 2020 or 2022, just this past March, released what's called a bold decadal vision for fusion energy, in which they endorsed fusion as part of the future energy mix and committed to seeing its development. And again, the $280 million was for the construction of pilot plants. If there was a framework in which there was some that offered that kind of certainty into investors, we may see more private funds coming. We are confident in our capacity to raise funds, but we would like to see a greater government commitment. We believe that would pave the way for more.
Government endorsed fusion energy?
It's in the process of doing that, and we are confident. There's regulatory engagement and engagement at all ministerial levels, but we are hoping for a national declaration and endorsement of fusion energy.
How many years have you been doing research on this?
We've been doing this for 20 years.
Yeah. Holy man. Okay, General Fusion is planning to build $400 million demonstration energy plant in the United Kingdom. $400 million is a very significant amount of investment. Why isn't this investment being made here in Canadian soil?
It's a good question. As I mentioned, our research and our labs will remain within Canada as we're building out the fusion program there. We did receive support from the United Kingdom Atomic Energy Authority to build for capital expenditures, which is something that is limited within our existing grant programs in Canada, particularly research-based capital expenditures. On top of that, as I mentioned, we are going to locate our demonstration program adjacent to the Joint European Torus, which has a record. It holds the longest record for net energy reaction. So we have access to their concentration of talent. We also will have access to a supply chain, and that space actually is already regulated for fusion energy and is inviting to it. So
is it UK endorsed fusion energy?
Yes.
So then I guess probably because Canada has not endorsed fusion energy, decided not
and
to
there is
build
no
here.
current regulation for fusion energy. We are very eager to see an opportunity to build out our first commercial site within Canada, and have struck a number of partnerships with entities like Bruce Power and the Canadian Nuclear Laboratories to ideally bring that here.
Okay. You mentioned in your submitted remarks Canada's, and I quote, Canada's well-known commercialization gap is what could hamper the potential for these disruptive technologies to be delivered to market, end quote. That's a very troubling statement. If this government fails to address a well-known commercialization gap.
Mr. Mazier, I'm sorry, that's the time. Perhaps you would like to ask Dr. Barber for a written response.
Sure. Yeah, that'd be good.
Thank you. And Mr. Mazier, I will also thank you for correcting the honorifics for Dr. Barber. This is really very important that we get this right. So I'd like to say thank you, and I would like to apologize to Dr. Barber. Thank you both. We will now go to Ms. Diab for 6 minutes, please.
Much, Madam Chair, and let me start by thanking both Dr. Barber and Dr. Smith for being here today. We're really honored to have both of you and your talents and expertise. Let me direct my question to Dr. Smith. We're here to study ambitious research goals that we hope will solve some of Canada and the world's biggest sort of challenges. And you, and I'm really happy that you ended with giving us your input in terms of what national strategy you believe Canada should be leading in a number of areas where you talked about sustainable health system, adequately staffed. I'm very interested in the one brain disease and dementia affecting so many Canadians. Can you tell us a little bit more about that and what can we do what can government do, what can we do as parliamentarians, and what can researchers and how do you how can you help as well and others help to move this along?
Oh, thank you for an excellent question, and again, the privilege of talking with you. Dementia and brain disease, organic brain disease, is particularly a disease of aging. And while Canada is still a young society relatively, we are, of course, an aging society. We also look at the expenditures of healthcare, provincially approaching 50 cents on every tax dollar during COVID and around 42 cents pre-COVID. So by far Canada's most expensive social program, and I would suggest possibly most valuable. When we look at dementia, remarkable basic science, a great understanding of the underlying issues of dementia and disease, wonderful clinical trials, fantastic infrastructure around better understanding population-based research as it relates to dementia and dementia care. And of course, more and more interest from philanthropy. When I look at the two foundations of the organization I work with, the Princess Margaret Foundation and the University Health Network Foundation, generous donors are investing $250 million per year in research and education through those foundations. When we bring together the remarkable scientists who are aligned around dementia care, and I would encourage you to also look more broadly into the technical disciplines as we think historically about traditional research teams. They wouldn't have included AI scientists and data experts and data lakes and all sorts of remarkable engineering colleagues, academic engineers. So we truly are at the cutting edge in Canadian science across literally every discipline. It can be brought together for a true moonshot on brain disease and particularly dementia, which we know is what most Canadians identify as one of their greatest fears of aging.
Thank you very much for that. My colleague had a question as well. I'm going to let Dr. Pawlowski here ask it. Go ahead.
A question for Dr. Smith as well. I think if you were to ask Canadians, like, what would be, in their judgment, the greatest moonshot, and I think it would be a cure for cancer. I think if you look at how both in Canada and globally we responded to the pandemic and how well we did, how quickly we came up with the vaccine, it really showed what was possible. Is the same thing possible for cancer? Is it a matter of having the political will and being willing to put the money in? Could we could we come up with a generalized cure or cure for individual cancers within a reasonable amount of time, should we be willing to put the money and effort into it?
I absolutely believe that we can dramatically improve the journey. Cancer patients in Canada have come a long way. Cancer has become, in many cases, somewhat a chronic disease, with recurrence of cancers occurring and people's mortality being dramatically reduced. When I look at childhood leukemia, particularly, almost eradicated. So absolutely, we have the capacity to do that. I also think the fact that the United States, with President Biden, has declared cancer their moonshot offers a North American consortia of cancer care and cancer research that also allows us to stop the brain drain. All of our most remarkable cancer scientists will be potentially drawn to the United States with an unknown investment in cancer prior to this commitment. And by aligning ourselves, because science knows no borders, as you folks know, we really and truly are able to leverage the investment of multiple economies. So I would absolutely enthusiastically endorse cancer as that moonshot.
If I still have time, you may want to use this
45 seconds, Dr. Pawlowski.
Any projects off the top of your head at UHN, cancer research, which you think is particularly promising?
Well, I think one of the things where the provinces and the government of Canada can come together as a first in the world cancer center, Princess Margaret and the broader Toronto cancer community, we do not have a number of facilities that we're seeing arise in the United States and other parts of the world, carbon facilities and beyond. And as we think about new treatment approaches that are proving less damaging to surrounding tissue and more positive outcomes, then I think we absolutely could focus again on new therapies and new treatments where Canadians currently have to leave the country for proven technologies. And,
thank you.
Sorry.
I'm sorry to interrupt. I apologize. As you can see, you have a very interested committee, and we're all very grateful for you both being here. We'll now go to Monsieur Blanchet-Jonca for 6 minutes.
Thank you very much, Madam Chair. Just to note that I'll be referring to my motion that was already tabled. It's 5 minutes before the end. I just wanted to make sure that I had time. And Mr. Smith, I have a question for you. The University Health Network refers to a number of projects in healthcare in order to develop new treatments that will improve, of course, the human condition in cardiology, neuroscience, oncology, infectious diseases, genomics, among others. So clearly, healthcare needs are enormous in this context. I'm wondering what you would think about how the government should allocate the funding for healthcare research.
Well, I think it's a great question, Monsieur, and I think the challenge obviously is that a moonshot where we're going to focus it and be very purposeful about outcome and metrics and measurement, or is it a continued investment through the tri-councils and beyond, including industrial research? And my own personal view is that it has to be both, or all of the above: philanthropy, the tri-councils, investment by provinces, investment in infrastructure, and then really coming back to a strategic plan within each of the institutions and across collaborative institutions who will in fact talk about what kind of investment we're receiving, what kind of results we're expecting, and then bringing together evaluators to ensure that Canadians are getting the greatest value for money, whether that's a traditional research measurement, so high impact journals, highly cited work that's translating into patents and discoveries that can then generate an economic benefit, or again, in a more traditional academic environment, the creation of basic science that can be exploited. So my own view is that we have a healthy research ecosystem in Canada, but we're at vulnerability. We're seeing other nations invest a great deal more, and we're seeing, as an example, at the National Institutes of Health, the current U.S. administration offering a $10 billion increase, which is actually the collective investment we make in the tri-councils. So to me, it means keeping pace with other nations' investments and ensuring that the brain gain we enjoyed 10 to 20 years ago continues, and that researchers see Canada as a bright and vibrant place to remain.
Merci, Monsieur Smith.
Thank you. That's very clear. So clearly, the moonshot projects would be focusing on a small number of projects, large amounts of money. The needs are obvious in healthcare and elsewhere. Does that not mean that we might be neglecting some other very important projects if we really focus on some major projects like the moonshot projects?
I think it does require us to discuss what's a healthy ecosystem look like, what's the continuum look like, and does it need to be a disease-specific moonshot, or could it be an underlying scientific theme that we understand has relevance to many disciplines and many diseases? Hence my comment on the inflammatory response. Almost all of the diseases where I work that are actually focused on inflammation and repair, be that heart disease at the Peter Monk Cardiac Center, or organ transplantation at the Ajmera Transplant Center, or brain disease at the Krembil Neuroscience Institute. The underlying theme is truly inflammation, repair, and the sequelae of inflammation. So one opportunity for a moonshot that would benefit almost the entire scientific ecosystem as it relates to health and human well-being would be to think about a very fundamental basic science investment. My own personal view would be that should be in inflammation.
Merci beaucoup.
Thank you very much, Mr. Smith. So we know that scientific research is highly global, extremely competitive. Countries are essentially rivals to keep the best brains in their countries and even draw others into their sphere. So Canada is competing with other developed countries. And again, Canada is the only G7 country that has seen a drop in the number of researchers in the last 6 years. I'd like to hear what you think is Canada's problem in trying to maintain and draw in these researchers.
Researchers, obviously, their first loyalty is to their science. As we look at where will they find the antecedent conditions for success, so availability of research funding, availability of funding for students, and your previous panel spoke about this, a livable wage for those undertaking fellowship training and beyond. The opportunity for the expensive infrastructure that many research endeavors have, not unlike what the Canada Foundation for Innovation invests in, and of course the unlimited demand for tri-council funding. We are unfortunately unable to fund a very large amount of excellent science. So the international competitiveness, however, I don't think has to turn us off or down. I see the green book, Madame Duncan, I'll be quiet. Just a quick thought. In looking at international science, I don't believe we have to bring everyone to Canada. I think we can look at models like the Canadian Institute of Advanced Research and buy pieces of the very best researchers anywhere in the world, and they come to Canada for periods of time. And that if COVID has proven anything, it's proven that we can collaborate around the world without movement, nowhere more so than science.
Merci beaucoup, Monsieur Smith.
Thank you very much, Smith. Madam Chair, I want to table my motion, as I mentioned.
Blanchet-Jonca, that's 6 minutes.
Okay.
Perhaps we could do that on a different round. I'm sorry.
Madame la Présidente.
Madam Chair, sorry, but I did ask you to interrupt me 5 seconds before the end so I could table my motion. Did you understand that?
Monsieur Blanchet-Jonca, I did it at the 30-second mark. Can we wait to do this to the next round?
Malheureusement, non.
Or,
Unfortunately, no, Madam Chair.
Parce que je crains qu'il y ait une possible.
Because I fear there may not be a second round for me. You know.
Je ne le vois pas à l'écran. Pour la motion.
So my motion, Madam Chair, I'll do this at record time. The notice of motion you've already received, colleagues, and I'll read it. that the deadline for the submission of briefs in relation to the study of research and scientific publication in French be extended to 5 p.m. on Thursday, December 22nd, 2022. Dear colleagues, Madam Chair, you know that I had already raised the issue earlier. And more specifically, to summarize, we are expecting Minister Champagne, the Minister for Science, Innovation and Development, in the fields of industry, for one. I've already invited the minister come and appear, and we had an agreement among parties, so October 30th, and the minister should be hopefully appearing soon. A number of witnesses, however, said that they wanted to table their briefs, waiting for the minister's appearance. I remain optimistic. We hear that it might be on December 12th that he might appear, and our agreement prior to that was 10 extra days to table those briefs. So that is why I'm tabling tonight's motion, the motion tonight.
Thank you, Mr. Blanchet-Joncat. Is there any discussion?
Sur cette motion, Madame.
On this motion, Madam Chair, I would call for the vote.
Thank you, Monsieur Lauzon. Is there agreement to call a vote? It looks like there's agreement,
Yep.
Mr. Clerk. Mr. Clerk, thank you very much.
So the question is on the motion. Ms. Bradford.
Agreed.
Mr. Collins.
Agreed.
Ms. Diab.
Oui.
Monsieur Lauzon. Oui. Mr. Pawlowski. For. Mr. Lobb. Oui. Mr. Mazer.
Oui. Oui.
Mr. Soroka.
In favor.
Mr. Williams.
In favor.
Monsieur Blanchet-Jonca.
Oui.
Mr. Cannings.
Aye.
Yeas pour
Yay.
11, 11, nays contre 0. Okay.
Thank you very much, Mr. Clerk, and thank you, Monsieur Blanchet-Joncat. And now we will go to Mr. Cannings for 6 minutes, please.
Well, thank you to the witnesses, as usual. Very interesting discussion. I wanted to start with Dr. Smith. And I just want to clarify something that I thought I heard you say, and maybe I heard it wrong, and that one of the moonshots you were talking about was a sustainable healthcare system, or were you talking about a research system?
No, I was actually talking about a sustainable healthcare system and thinking about how we would create that, which would include basic research as well as pedagogical or educational research. Okay,
good, because I was a bit surprised to hear that, but happily surprised because, I think Canadians, 100% of Canadians would say they would be very interested in hearing about a sustainable healthcare system. And I'm just... Perhaps I want you to expand on that with a bit of background. I remember one of the first things I read when I was getting into politics 10 years ago was a book by Jeffrey Simpson on, I forget what it's called, chronic care or something like that, about Canada's healthcare system. And he went through various ideas about how we could improve the system, make it more sustainable, and kind of ended with the fact that if you look at the systems of the world, the healthcare systems of the world, those with the best outcomes for the money spent were those more or less in Northern Europe, where they invested in people up front, made sure they were well educated, made sure they didn't fall into poverty, make sure they were stayed out of hospitals, stayed out of jail, all those things that, the social basis of health. And then they had a good healthcare system that could run properly, but it took that upfront investment. And I'm just wondering if you could comment on that, if that's still one of the pillars of a sustainable healthcare system.
Absolutely, Mr. Canning. When one thinks back to the chamber in which some of you were sitting, I believe it was Monsieur Lalonde in the early 1970s who really introduced population health, or the health of the population, to Canadians. And that really means not only an illness care system for when people are sick, but recognizing that education, housing, food security, eradication of poverty, good drinking water, those are incredibly important components of health. And of course, for illness care, strong delivery mechanisms. We know currently one of the greatest challenges facing our healthcare system is adequate health human resources. And that is not unique to Canada, but around the world. When one thinks about the economics of healthcare, it is one of the most expensive social programs, yet, of course, one of the most important, although I am a tiny bit biased. That having been said, if we really want to look at the effectiveness of the system, often we need to look at the incentives that we've put within it. So I could think of a moonshot and looking at the sustainability of a healthcare system that would include economists thinking about how we can better fund the system and better align our incentives to the outcomes that we're hoping for. Thinking about data scientists and artificial intelligence experts who can help Canadians make better individual decisions. Thinking about digital health that allows people with chronic diseases like congestive heart failure or chronic obstructive pulmonary disease be able to be managed at home using downloadable wearable devices, which are actually made right here in Canada by remarkable companies that are actually more attractive on the international market than often our own Canadian market. So, and last but certainly not least, who are the extenders of physicians and nurses and therapists that we know could and should be brought to the healthcare system to make that health human resource issue go much better. So one could easily think about a science, social science, economics model of care where we would bring together the truly most interdisciplinary team one could imagine to address both population health and the healthcare system of those who are ill and require treatment.
Well, thanks very much. I'll leave it at that because we could talk about this for days, I'm sure. But I wanted to turn to Dr. Barber and just, we just did a study on small modular reactors, and the government, I think, has come up with funding almost $1 billion to support small modular reactors, yet they don't seem to be supporting fusion at the same level. I just wonder if, with the time remaining, if you could maybe compare where fusion is versus small modular reactors. You say you'd be on the grid by 2030. And what are the ongoing costs to that? How would the costs of fusion energy be compared with SMR energy?
We do have a timeline to be on the grid that's relatively comparable. We have received government funding in terms of SIF, IRAP, SDTC, but again, we are seeking a larger strategic partnership and contribution, say, with the government, and have proposed a structure where it would be warranties which would position the government as an equity partner as part of a large raise that we're currently in, much like the one that has just been awarded through Ontario Power Generation and in partnership with the provinces. So we are seeking opportunities like that, federal government in partnership with other national governments, say the UK, and or with provincial partnerships. So our timeline for development and deployment is approximately the same. So yeah, that's what we are seeking, and we do hope for endorsement.
Thank you, Dr. Barber, and thank you, Mr. Cannings. Thank you to both our witnesses tonight. And now we're going to go the 5-minute round, and I see we have Mr. Williams. It's lovely to have you back. Mr. Williams, the floor is yours.
Thank you, Madam Chair. It's lovely to be back, and thank you to our witnesses here today. I do want to start with Dr. Barber. Very fascinating. It does seem like this is a definite moonshot. I want to start with why Canada? So why do you think Canada has the potential to be a leader with fusion?
Thank you. We have all the components that we need here. We have the labs. We have the fuel source out of Ontario, the Canadian Nuclear Laboratories. We have utilities that are interested in the transition. I was just in Alberta, and they've actually transitioned away from coal much earlier, and I'm sure they would transition away from the intermediate source of fuel even sooner if something like this were to be available. We have a history of energy development and leadership. We are climate leadership. We're climate leaders as well internationally. We have an excellent reputation. We would be a politically safe source from which to export this technology, particularly in light of the current crisis and geopolitical energy security challenges. And again, we have the academic institutions. I'm constantly coming across people that work for, say, the University of Alberta, University of Saskatchewan, UBC, who have a background in plasma physics or in particle science or materials science, mechanical engineering. So we have all the constituent components. We just need to bring them together into a formalized and committed program and have that policy commitment underpinning that.
I know you might be a little biased, but if you were going to rank this technology compared to hydrogen, compared to small nuclear reactors, where is this technology going to be in terms of prominence? You discussed the target of almost 3 times our energy needs in the next 20 years. Where would you put your technology?
Well, we are completely carbon-free and no atmospheric emissions, so I think that goes to say where it would be on the priority. However, as I mentioned at the beginning, there's room for all of these technologies to meet our future energy needs. And we really say that the only competition right now is the status quo if we're going to get to where we need to be.
One of my colleague was asking about the commercialization gap. We are studying this very soon, so you might ask you to come back. But when it comes to commercialization, commercializing your IP, what do we need to do? What recommendations would you make for us?
Well, I would reinforce our ask for the government to be an equity partner through warrants and to invest in a long-term program that is stable and takes us outside of traditional grant requirements that either seek to limit capital investment in research and development. But I think it's also a question of keeping the talent here and then building out the manufacturing capacity and the supply chain. Canada, we're really good at seed financing and we're really good at producing our IP, but when you look at, I think it was the C.D. Howe Institute that looked at how much the copyright or the licensing of that IP gets taken away by other countries. So we don't want that to happen with our technology. We want to be able to manufacture the kits here. We are a technology provider in the sense that we don't plan to own or operate our plants. So that gives us opportunity to build them out here, but it also gives us opportunity to export our technology and to make government revenue from that.
The U.S., I see it as our biggest competitor. The U.S. Energy Board has Earthshots, so they're investing heavily in hydrogen, energy storage, carbon, geothermal, wind. So when I say moonshot, it seems like we finally have a differentiator. We have something that Canada can excel at. But, you know, the Inflation Reduction Act the U.S. has just implemented has a lot of money compared to us. And, you know, we're looking at European nations who are looking to bring their green power to the U.S. $391 billion is what they're investing in green energy. That would be equivalent to about $39 billion for Canada. Is it just money, though? What else do we need, I guess my main question, my last question, to be a differentiator? You mentioned a couple things, commercialization, research, R&D. But what do we really need to ensure Canada is the world leader in fusion?
I think we have to consider creative partnerships like the one that we put forward in terms of strategically partnering with the UK on becoming an equity partner. So leveraging the private interest in fusion and considering the fact that you would, the Canadian government would get direct returns on its investment that way.
Madam Chair, I think I'm all done. Thank you very much.
Thank you.
Thank you, Mr. Williams. It is lovely to have you back today. And with that, we will go to Ms. Bradford for 5 minutes, please.
Thank you so much, Madam Chair, and thank you again to Dr. Barber and Dr. Smith for being here with us tonight. So just to get it on the record, I just wanted to point out, clarify with you, Dr. Barber, the Canadian government has made substantial investments in your company, right? Yes. Did you want to just review what the dollar value is of that?
So approximately, if combined, it equals over the 20 years to about $100 million. So we are very grateful for that, and we are that funding round does come to a close, or that funding will come to a close the end of 2023.
Okay, great. But At least it does show that the Canadian government does recognize
Absolutely, and it's
the
been
value of
critical
this
to our
technology and that it has certain, great future. Okay, so Dr. Smith, I have a couple of questions for you as well. Moonshot goals are supposed to be extremely ambitious goals. How can the government help mobilize the research committee and the general public behind trying to solve some of the biggest issues of our time?
I think identification of what exactly the goal looks like, feels like, and the time frame to get there. So I think the most successful moonshot goals first identify what is the problem, what percentage or what proportion of Canadians would agree. That is, of all of our social pressures, of all of our most challenging issues for Canadians, it ranks in their top 1, 2, or 3. And then looking at the kinds of resources that Canada already enjoys. In the case of research, a very strong research community, opportunity to leverage investment, a strong commercial presence, be that in either of the topics that myself or my colleague presenter this evening have talked about, healthcare or energy. And last but certainly not least, productive analytics that allow us to show Canadians that we're making progress on the world stage. I think few Canadians are interested in saying, I'd like to have the best cancer system or the best energy system in Canada. They want the best cancer system or energy system in the world. And how can we demonstrate that Canadians will enjoy that with these investments?
Thank you. That's very inspiring and an inspirational and aspirational goal. So now here's a question that you might find coming a little bit out of left field. But I do know that you're a professor with the Department of Medicine at McMaster University. And I am aware of the bat lab there. Now, bats have been a topic of conversation tonight. I don't know if you were following the previous panels. Can you tell me, to your knowledge, and I'm sure you're aware probably, of what kind of research they're doing in the bat lab at McMaster? I find it quite fascinating.
I'm going to embarrass myself a little bit because it's not an area that I know well. In my history, I was full-time at McMaster before coming to Toronto. There was a remarkable man named Dale Buchanan who was known as Batman. And much of the research looked at 3 things within bat colonies. One, the saliva of bats and its conditions for the prevention of blood clotting. The other that I know of is the spatial array that bats have in terms of the equivalent of the most advanced sonar known to man and looking at geospatial positioning. But beyond that, I would be happy to follow up with a note to you and speak to my colleagues who are much more knowledgeable.
That'd be great. So then probably this is my final question, so leave on a high note with me. In 1961, JFK challenged the nation to put a man on the moon before the end of the decade. And 8 years later, mankind was on the moon. So, fast forward 8 years from now, what would you like to see Canada achieve? I think you alluded a bit to that earlier, but what do you think the goal, where we could be in 8 years?
Well, I actually think selfishly, any of the above we discussed, I personally think the most important thing that Canadians are struggling with today is access to high quality well-being and healthcare. And so I would say I'd love to see that Canada has the world's best healthcare system, realizing the best outcomes and the highest health of the population, and that our healthcare workers are among the most satisfied and rewarded in the world. At the moment, we're challenged, but I have every confidence that all of the antecedent conditions are there. If we were to make that an objective, we could realize that goal.
Well, I agree. Affordable and accessible healthcare does seem to be a current challenge right now, but it's definitely one worth focusing our efforts on. And it probably is a moonshot at this point from where we are. But thank you so much. I don't know if I have any more time, but I'll cede it to whomever, Madam Chair.
You're still muted. You're muted, Madam Chair.
Thank you, Dr. Smith. You would think you wouldn't do this at this point. Dear colleagues, I'm afraid we've come to the end of our night together. And our first order of business is to thank our 2 witnesses. Dr. Barber, Dr. Smith, we're grateful for your time coming and sharing your expertise. We are very, very grateful to you both. And with that, you are welcome to leave. And we have some committee business, but I would like to once again thank both our witnesses. Thank you. And with that, dear colleagues, I do have a little business to do with you. Say good night. First of all, colleagues, are we good to go, Mr. Clerk?
Yes, we are in public, but we're good to go.
Thank you very much, Mr. Clerk. Colleagues, first of all, thank you for great discussion tonight. And we do have an order of business we have to get through tonight. The clerk has kindly distributed the latest version of our proposed travel budget for the trip that is currently planned for February 19th to 25 of 2023. This is based on the info received from our committee and the sites who will be hosting us. As you know, today's meeting is the last chance to adopt a budget for our planned trip before the deadline for submitting it to the committee we have to, the SPLE. And are there any questions, or can we entertain a motion to adopt this budget?
I would be happy to move a motion to adopt the budget.
Thank you
Mr.
so
Cannings
much.
moves it, and we all second it.
Is there agreement in the room?
Yes.
Thank you, Ms. Diab. Thank you, Mr. Cannings. And that, dear colleagues, will say adjourn. Thank you, one and all.